Hello everyone, welcome back to this channel. I am very excited to announce that I am going to start a new course on SQL. I will create a playlist where I will explain everything regarding SQL. And I have also created a blog. You can take short notes from here. Okay, now let me explain what is SQL. The full form of SQL is Structured Query Language. Okay. Now let's imagine that you have your own company and in your company you have employees, so you have to maintain the details of their employees, right? So now you have created two tables. So employee table, and you have created one more table in which department and employee is posted. So in this table you have kept ID, name, age, address, all the personal details of the employee. And in department table you have kept ID and in which department they are posted. Okay, so you have A employee, B employee, C employee. Same here, you have details employee A, employee B. So all these details are known as data, right? And this particular thing is known as table, and the complete thing is known as database. So a database can contain multiple tables. Fine. It may contain 2, 3, 4, 1 or multiple. Now another term is known as relational database. What is relational database? Let's say I am telling you that please give me the name and the department of any particular employee. So you have to fetch the data from employee table, the name, and from the department table. So you have to create a connection between them. How can you create the connection? You can see the ID column that is present here also, that is present here also. So you can take up that particular column and you can create a connection between them and give me the desired output, right? So there is a relationship between the employee table and the department table. So when there is a relationship between a database, that particular database is known as relational database. So we can write when there is a relationship between tables. So most of the time we will work with relational database only. Okay. Otherwise, what is the benefit of having a database if there is no relationship? You may have any number of tables. So only this relationship will help you to fetch the desired output, right? Now let's say how I will instruct this database to give me any particular output. For that you need a language, right? So you are the client and you are asking some details from the database. So you have to communicate using any language. That particular is known as SQL. That is what we are going to learn. How to talk to the database, right? So you may need to create the table. You may have to insert the values in the table. You may need to delete some values from the table. You may have to fetch some values from the tables, right? So you have to perform various kind of operations in your database. For that you are taking the help of SQL. But to do different kind of operations, you have to provide different types of commands. So these are known as queries types. So it is of many types. First you think that you have to create the table, right? Otherwise you can't do anything. So you have to create the table, you have to create the database. So first one is DDL, which is data definition language. Data definition language will help you to create and restructure. Create, or if you want, you can restructure it later. To do this, you have to use DDL. What are the keywords? It's like create, alter, drop, or delete. Okay. These are the keywords using which we will write the SQL commands to perform these types of operations, to create a table or to restructure a table, to make some modification in the table, delete a table. Okay. So these types of queries are known as DDL, data definition language. The next one is DML, that is data manipulation language. You have created the table, but you have to insert some values in the table, right? You have to insert the details of A employee, of B employee, of C employee. So for that you have to take help of DML. DML is to manipulate data within objects of a relational database. Okay, now it may be insertion of values, update, maybe there need some modification, or you may need to delete. Okay, so these things are done by data manipulation language. Now you have created the table, you have inserted the values in the database. Perfect. Now I want to fetch some data from the database. So for that you have to write a different kind of query which is known as DQL, data query language. This is the topic where we are going to spend most of our time. So here you have to use the select keyword to fetch something, to see the details. Okay, so that you can take some decision. This is known as data query language. Okay, this is the main focus of SQL. Now DCL. This is about data control language. Once you have created your database, you are not going to give control to anyone and everyone, right? So you may need some control over the database. So for that you can use DCL. Here you have to use grant, revoke, these things. Okay. Now the next one is data administration command. Data administration command is performing different kind of audit, or you can say that perform analysis on operations within the database. So data administration commands. Perfect. And the last one is transaction control commands. Sometimes you may make some mistakes, or sometimes you may change your mind. So you should have some options that you can go back to a particular point. So that is transaction control command. It's like commit or rollback to manage the database transactions. Okay, so this is all about SQL, and we are going to learn these things in detail. And what we are going to focus mainly, that is DQL, data query language. Okay, so I hope you have liked my explanation. Please subscribe to my channel. I will try to explain everything in detailed manner. So meet in our next video. Till then, bye. Happy learning. Today we are going to learn about types of databases. It may be relational, NoSQL, column database, object oriented, and many other. Today we are going to learn about these databases. Okay. So first, tell me, why do we need so many types? Why? Because your data may be a photo, maybe a video, maybe some YouTube comments, or maybe details regarding the employees. Okay, so your data can be many types. Depending on this, you have to select which types of database you are going to use. Perfect. Now, the first one is relational database. Relational database means in that database there is a relationship between tables. In your company, let me write here. In your company, you have to keep the details of the employees. Okay, so you have created two tables. One is employee table, another one is department table. So in employee table, you are keeping their personal details, their ID, name, age. In department table, you are keeping ID, department. Okay, now you can create a connection between these two tables using this ID column. So we can say there is a relationship between these tables. Okay, so the complete thing is known as database, and there is a relationship using the ID column. So we can say this is a relational database. In this database, a relationship is existing between these two tables. Okay, and you can keep your data in row format. So it is structured. Okay, so for these types of data, you have to use relational database. And for using this relational database, you have to talk to the database, and for that purpose, you have to know SQL. That is structured query language. Now the second type of database is NoSQL database. Here you cannot use SQL. If in your Instagram profile, I tell you that keep all the comments in a particular database. So tell me, can you write that in a row table format like this one? Because in your Instagram, you can have one comment. There can be many more sub comments. and in response to this comment there can be many more sub comments. So is it structured? Can you write this in this tabular format? No. So for these types of data you have to use NoSQL database, and one famous database you may know is MongoDB. Okay. Now the third one. Now the third one is column database. What is column database? See, here we are keeping them in row manner. So I can say that this is ID 1, 2, 3. Name A, B, C. Age 30, 35, 40. Okay. Now if I tell you to keep this thing in column database, what you have to do? You have to write in this way. ID, name, age. So ID 1, 2, 3. Name A, B, C. Age 30, 35, 40. Okay. Okay. And these types of column database is mainly used for analyzation. Okay. Amazon Redshift, Google BigQuery. So these are the example of column database. Okay. And the next one is object oriented database. If you know what is object, object is an instance of a class. So here you keep your data in object format. It's like, let's say you have a car. So you will write car type, car model, car manufactured year. Okay. So in this format you keep all the details of car. The car is an object. Okay, clear? Here you can take the advantage of polymorphism, inheritance, all these things. Okay. So in that scenario you use object oriented. Now what is the fourth one? Hierarchical database. Hierarchical database, where you have to maintain a hierarchy. It's like in your company you want to keep the details in a hierarchical format. So you can write in this way. Company, here you write HR department. So here you mention about employee A, about employee B. You have another department, sales department. Here you mention about employee C, employee D, one more department. Okay, so you are keeping in a hierarchical manner. In that scenario, you have to use hierarchical database. Okay. Now the next one is graph database, where you create graph database. This database is mainly for storing graph structured data. Let me show you an image. Graph database. See, it looks like this. Okay, it looks like this. In this format, if you want to store your data, then you have to use graph database. Okay, Amazon Neptune, these are the example of this graph database. And the last one is key value database. The last one is key value database. This is kind of like a dictionary where you have a key and you have a value. Let's say if I write key and this side I write value. Now you have user ID 1. So for this you are keeping name, name is A, age, age is 20. Sorry. Same for user 2, you write name, B, age 30. Okay. Okay, so you are keeping the data in a key value format, that is known as key value database. Okay, and examples of key value database is DynamoDB. Okay, so we have understood what is relational database when there is a relationship between different tables. NoSQL database when it doesn't follow any strict table row format, so SQL cannot be used. That is why it is NoSQL database. Column database where you store the data in column manner rather than making rows. Number fourth is object oriented database. Object, everything is like an object here, so you have to create some properties. And like make, model year, methods for car rental service, and you can take the advantages of different kinds of polymorphism, inheritance, what are the properties of object, like that. Next one is hierarchical database. Hierarchical database is where you maintain a hierarchy, organizational chart, like CEO is at the top, then you can write the managers, then you can write about employees under each manager, like this way. Okay. And next one is graph database, where you create a graph to make a connection, like recommendation system, like social network connections. And the last one is key value database, where you have a key and you have corresponding value. Okay. So depending on your need, you can choose which types of database you are going to work with. But here we are going to learn about relational database, and we are going to learn about the SQL queries that is helped to work with relational database. Okay, clear? So bye, happy learning. Today we are going to understand some database related terms. Let me write database related terms. Before you learn this, you should be aware of these terms because you are going to use this frequently. Now see, first one is rows, or we can say records. Every individual row, john.doe@example.com, the name, John Doe, salary 60,000, age 30, department ID 1, this is a row, or we can say this is a record. Okay, clear? Second term is columns. Columns. Email ID, name, salary, age, department ID, all these things are individual columns. This is also known as attributes. Okay, we can say the features. Salary, age, name, all these things are columns or attributes. Okay. Now the third one is table. The whole thing, this is a table where you are keeping the details. Okay. And number 4, database. Database is multiple tables. This is about some details. You may keep some other details in a different table, and all these things together is known as database. Okay. Let me clear. It's known as database. Now the next one is data types. What are the data types? See, here I have kept something varchar, or we can say character, but here I have used numerical values. Here I have used numerical values. Here I have used characters. So these are known as data types. Whenever you are creating the table, you have to specify whether the value will be numeric or the value will be character or something else. If you have some date time column, then you have to insert data which is in date time format. Okay, so these things are known as data types. These are important because it may happen that someone is in giving some numerical values in name column, so that is absurd. That is not possible. For that purpose, you should have different kinds of appropriate data types. Okay. Now the next one is null values. What is a null value? Null value means nothing. See here, no value is there, no value is inserted, no value is inserted, no value is inserted. So these values are called as null value. Because when you will create the table, you have to say that name column must not be null, salary column may be null, age column may be null, department ID column must not be null. So for that purpose, you should have to use either null or not null. Syntax we will learn later. Okay. Now the next one is constants. What is constants? If I provide something like JDOE in the email ID, then do you think it is valid? No. If I provide 150 in the age column, do you think it is valid? No. So for that purpose, you mention some constant, so that whenever someone insert any values into the table, they must follow those rules. If it is email ID, there are some obviously that at the rate will be present over there, right? If it is age, then it must be in some range like 25 to 85, like this. Okay, so you are putting some constraints on the table. Those are known as constraints. Okay, clear? So rows, individual rows, columns, every column, table, the complete thing, multiple tables called as a database, the data types, whether it is integer, character, varchar, date time, numeric, float, depends. Null values, whether there should be a value, must be a value, or there can be null values. Okay, and next one is constant, where you are giving some rules to be followed while creating the table. Okay, clear? Today we are going to understand data definition language. SQL commands are of many types: DDL, DML, DQL, data administration command, TCL, transaction control language. So today our topic is DDL, data definition language, for defining and for modifying the database structure. You have to create the database, you have to create the tables, you can make some changes inside the tables, you can delete those tables. All these things comes under data definition language. Okay, these things we are going to learn today. Now first, your company, so you have to create a database. Let's say company database you will create. Okay, and inside this database you will create multiple tables. Perfect. Now I will open MySQL workbench and there I will show you how to create a database. Okay, let me close this. Uh, okay, okay, fine. Now let me write create database name. Let's say our database name is company. Okay, so if I select this and execute, see here green tick, that means the query is executed properly. So create database company, one row affected, database is created. Here if you click in schema it will show, but sometimes it takes time to get refreshed, or click here. Okay, see the company database is created. Okay, now if I tell you to create database company, if I execute this again, then what do you think the output will be? It will show you an error because the company is already existing. See, it is an error. But tell me, is it possible to know that whether the same name is used before or not? No, that is a difficult thing. So you will get error, but that is not expected. You have to handle the error. For that, you can write if not exist. That means you are instructing if it is not existing, then create this. Otherwise, okay, don't show me error. So it will give you an output of, sorry, the query problem exist. See, if I run it, see now it is an warning, not an error. So it is saying that we cannot create because that is already exist. Okay, so whenever you create a database, you try to write in this way: create database if not exist company name. Let's say I'll change our company. Now this is not existing, so it will be created. It will not show any error. Okay, now check in schema, refresh this. See, our company database is created. Perfect. Now inside this database, you can create multiple tables, right? Or if you want, you don't like that particular database name. So if you want, you can change that also. You can delete that particular database. Let's say I don't need company database anymore. So I want to delete this. So I can write drop database name. Okay. Now if I execute this, I'm sorry. See, it is executed. Green tick. Here also you cannot see company anymore. So the database is deleted. Okay. Now if I try to delete that database again, so again I write drop database company. What do you think the output will be? The database is already deleted, so it will not be able to find that database. So it will show you an error. But you have to handle the error. So you will write if exist. It means that you are instructing if the database is present, then only delete this. Otherwise, don't show me an error. So it will show you an warning only. It will not give you an error. Okay. So this is the way you can create or you can delete a database. Okay. So we have learned how to create a database. Second, how to drop or we can say delete a database. Okay. So the first keyword is, the keyword is exist and not exist. If not exist, if exist. Okay, fine. Now the next one. Database is created, so you have to create table. Now you will create the first table. This is created company. So you have to create the first table, that is employee table. Okay. Now see. I think we have deleted all the databases. Or do we have? Okay, we have our company. So inside this database, we are going to create the tables. Now, there may be many databases. So if I directly write create table command, then there will be a problem like in which database. Okay, they will get confused. So you have to write use our company. Now, if I execute it, our, sorry, let me execute this. See, now it is instructed that please use our company. Now see, tables created, views created, stored procedures, functions, these things we will learn. Today we are going to create a simple table. Now, if I want to create a table, let me write this here. So use database. Now we are going to create a table. Now see how to create a table. The command is create table name. Our table name is employees. Okay. Now first column, let me show you first. I want to create a table where there will be ID column, there will be name column, position and salary. So 4 columns. So now see how to write. Create table ID. You have to mention which types of data type you have to use. So you write integer. ID will be an integer. Okay. Now name. Name will be character. So we can write varchar and how many of maximum 100 length. Okay. Now position. Position you have to give varchar like manager, senior manager, project manager, CEO. Okay. Next one is salary. Salary will be numerical. So you can write salary decimal value and 10 comma 2. After points there will be two values. Okay. So you have to mention the column names and the data types. Fine. Now close this. So now if I execute this, see created. So if I click here, let me refresh, employees table is created. Perfect. You understand what I am doing. First we have created a database. Now we have created a table. Now let's imagine that I want to delete this table. Okay. DDL command is for creating, modification, deletion. You are working with the structure of the table. Okay. So we are going to delete the table. So we can write truncate table employees. Now if I select and execute this, okay, see it is green tick, that means it is executed. But you can see the employees. If I refresh, see then also it is showing you. Why is that so? Because the table remains the structure, the columns, the constants, but it deletes the data from the table, all the rows from the table. We have not created any rows, so that's why we are unable to see. But let's think that I want to delete the structure also. I don't want my memory to be occupied. I want all these things to be deleted. So for that case, you have to write drop table employees. Now if I select this and I execute this, now see, nothing is visible. Okay, clear? So you understand the difference between truncate and drop. This is a common interview question. Truncate means it will delete the rows from the table, but the structure, the columns, the constants, those things will remain inside the table. But drop table means you are completely deleting the table. Structure is also deleted. Okay. So we have understood how to create a table, how to truncate a table, and how to drop a table. Okay. Okay, now the next one is alter a table. You have created the table and you don't want to delete that, but you want to make some changes. let's say you want to add one more column. So you want to add address also. Okay, so you are not going to delete the complete table and creating it again. You will just do a bit modification. You are going to add a column. So add a column. Now let's see how to do this. So we will write, we have to again create the table. So I will execute this again. So see, table is created. Perfect. Now alter table name, alter table name, add, and column name is, we are going to add address. Okay, so address, and you have to provide further address will be varchar 100. Okay, now if I run it, select and run. See, now if I see the employee table, you can see here ID, name, position, salary, address. Okay, clear. So you can add one column. Now I want to delete the position. Okay, how can I do this? So you can write alter table name, and you want to drop column, which column? Position, column name. Okay, so alter table name, drop column name. Now if I select this and execute, see, now deleted. Oh no, it's not. See, now it is deleted. Okay, so you have understood how to add any column, how to drop any column. Now let's say I want to change the salary from decimal to integer. Just think that I want to do this. So I want to make simple change, alter table employees. That column is already there, so you have to write modify. Now the column name is modify salary, and now I want to give it a integer. Now if I run it, see, it's changed, and if I refresh this, see, salary has become integer. Okay, so you have understood how to add a column, modify a column, and delete a column. Okay, this is all about DDL commands. You have to create a database, you can delete a database, you can create a table, truncate any table or drop a table, and alter any particular table. Okay, these things comes under DDL. Fine. Okay, now if you want, you can refer to this blog. See here, data definition language, how to create a database, how to drop a database, how to create a table. Here I have given these things also. You can take short notes from here. And you have to do the practice. I have made a video how to install MySQL Workbench. So install and practice it. Okay. Bye. Happy learning. Today we are going to understand data manipulation language, DML commands in SQL. Using DDL, data definition language, you can create a table, you can alter any table, or you can drop the table. So once your table is created, the table structure is ready, you have to insert the values inside the table, or you may need to delete the values from the table, or you may make any modification in the values of the table. So for that purpose, we have to use data manipulation language, which is DML. So we have to insert, we can update, or we can delete. Okay, so for this we have to use data manipulation language. Okay, first let's create a table, then we will put the values inside. So our table structure, name of the table, let's say employee ID, email, name, salary, department ID. Okay, this is the table structure, and we will insert the values inside this. Okay, now let me open my SQL Workbench. From there I will tell you how to insert, update, or delete any particular row from a table. Okay, first let me create a database. Create database, our company. So now let's run it. Our database is created. Now use the database name. These are all DDL commands. You have to create the database. We are going to use this database. Inside this database, we are going to create a table. So create table employee and ID. ID, let's say integer. Name, name varchar 100, and what was our table structure? Email ID. Okay, sorry. So email, email obviously varchar 100. Okay, name. Now salary, let's say decimal 10 comma 2, two values after points, and department ID. Okay, this is our table structure. So let me run this. Okay, sorry, what is the problem? Oh, sorry, department ID integer. Okay, you have to mention the column names and the data types. Okay, now clear. uh, Let me refresh this. So you can see tables, employee table is created. If you click it here, you can see that no values inside the table. Perfect. Okay, so now we will insert the values inside the table. So for that, the keyword is insert into table name employees. You have to mention the column name. So our column name is ID, email, name, salary, and department ID. So now put the values. So the keyword is values. Okay, insert into is the keyword, values is the keyword. So values, now you will tell for ID insert 1, for email ID insert mike@gmail.com. Okay, now for name insert Mike. Okay, for salary 10,000. Okay, for department ID 1. Fine. So now if I select this and execute, it is not employees, it is employee, my mistake. So not S, that is why it is saying not exist. Okay, now see, if I click it here, see, it is inserted. Clear. Now if I want to insert multiple values, then we just have to put a comma and put the values again. 2, now a@gmail.com. I'm sorry. Now the name is A, salary, and the department ID. Clear. Now if I run it, let me click it here. Okay, this time we have inserted two values. That's why you can see the repeated rows. Okay, so in this way you can give comma and you can write as many values as you want. Okay, you can insert multiple values also. Fine. Now you have inserted, but you want to delete some values. You want to delete all the employees who are in department ID 1. Okay, so for that you have to write delete. So I will write delete from table name. Give a condition where is used for giving a condition where department ID equals to 1. That means only affect those rows where the department ID is 1. Now if I execute it, so let me click it here. See, the first two rows are deleted because those had department ID 1. Clear? Now let's say I don't want to delete the values, but I want to update the values. Okay, I want to update the email ID of A. Okay, so I will write update table name. Our table name is employee. Set, update is the keyword, set is the keyword. Set email equals to alice@gmail.com, where give the condition, where any condition you can give, like id equals to 1. But for that case, not id equals to 1, for id equals to 2. Let's say for this one, for this value I want to update the email id. Okay, so you have given a condition and you are updating. Okay, now if I execute, see, let me click it here. See, the email id has been updated. Clear? So you have understood how to insert the values, how to insert multiple values. Insert into is the keyword, values is the keyword. How to delete any column from the value, delete from is the keyword where you give any condition. Now how to update, for that you have to use update, table name, set, your whatever you want to set, then the particular condition. These things comes under data manipulation language. Okay, bye, happy learning. Today we are going to understand keys in a database. Keys means set of columns or set of attributes that uniquely identifies a record in a table. Okay, so which are the columns you can use so that you can uniquely identify any table. First, let me tell you a scenario. See, if I input employee ID 1, first name, S, T, salary, hire date, department ID, email id as@gmail.com. Fine. Second entry 2 as you something again as@gmail.com. Do you think this is valid? Do you think? No, this is not valid. Both of them can never have same email id. Same way, if I write again 2 as something something some email id, is it possible both of them have same employee id? That is also not possible. To solve this kind of error, we can use the keys. These are the keys. How to define them? While creating the table, create table, while using this statement, you can define the keys so that whenever someone makes any wrong entry in your database, it should not allow it to do it. Okay, and also it helps you to create relationship with different kinds of tables. So today we are going to understand these keys in depth. Okay, now the first one is super key. See, super key is a combination of column that uniquely identifies a row in a table. Okay, just focus in this part. Combination of columns uniquely identifies a row. Okay, now tell me first combination. Employee ID. Tell me, can employee ID uniquely identify a row in a table? Yes, because everyone's employee ID is unique. So if I tell you that employee ID 2, then you can uniquely identify a person, employee ID 3. Everyone is unique. Okay, there is no confusion. But if I tell you some name, like the first name Alice, do you think that it is possible to uniquely identify? No, there can be many people having the same name. Okay, so if I tell you first name, is it possible? No, it cannot identify. So F name cannot be a super key, but employee ID can be a super key. Fine. Next, last name. Do you think it is possible? By using last name, you can uniquely identify a person. No, many people have same last name, so it is also not possible. Salary, never possible. Hire date, no. In the same date, many multiple people can be hired. Department ID, multiple people can be posted in a same department. Email id, email id is possible because email id cannot be duplicates, right? Everyone should have unique email id, so by email id also you can uniquely identify any row. Okay, so whenever this combination satisfies, you can call it a super key, right? Now I said combinations, so you have to try out the other combination also. So now if I tell you employee id and first name, so if I write employee id first name, do you think that this combination can uniquely identify a record in a table? Yes, because employee id can identify, then combination also can identify, so this is also a super key. Okay, next combination, employee id last name. Do you think this is possible? Yes, no confusion, because employee ID can, then employee ID last name also can. I'm really sorry. Okay. Next combination. Employee ID, salary. What do you think? Yes, it also can be a super key. Employee ID, hire date. Yes, it also can be a super key. Employee ID, department ID. This is also can be a super key. Email ID, employee ID and email ID. This is also possible, right? Now if I tell you combination, first name with last name, possible? No. First name with salary, possible? No. First name with hire date, no. In the same day you can hire two people having same first name. First name, department ID, no. Same first name, employees can be in the same department. First name, email ID, is that possible? That is possible, because email ID can uniquely identify, so first name and email ID also can uniquely identify, right? So using this combination, you can identify any particular employee, right? Because two people cannot have same email ID and first name, because two people cannot have same email ID, so they can never have the same first name and same email ID, right? So this is also possible. Now if I tell you last name with salary, possible? No. Last name with hire date, no. Same last name, same hiring date, possible. Same last name, same department ID, possible. Same last name, same email ID, possible? No. So it can uniquely identify. So last name, email ID. Two people can never have same last name and same email ID, because they cannot have same email ID. So this combination also can become a super key. Now tell me, salary, hire date, possible? Never. Salary, department ID, possible? No. Salary, email ID, possible? Yes, possible. So I can write salary, email ID is also possible. It also can be a super key. Now hire date, department ID, possible? No. Hire date, email ID, yes, possible. Hire date and email ID. Okay. Now tell me, Department ID, email ID, yes, possible. So department ID, email ID. Okay. Now if I take combination of employee ID, email ID and first name. Let me write employee ID, email ID and first name. Do you think that it can be a super key? Yes, because employee ID can itself uniquely identify, email ID can identify. So any combination which can identify is a super key. So this is also a super key. If I say employee ID, last name, email ID, that is also possible to become a super key. Employee ID, salary, email ID, that is also possible. Employee ID, hire date, email ID, that is also possible. Employee ID, department ID, email ID, that is also possible. Okay, so you understand these are all possible super keys. Okay, now if I write the last one, this is the way you can check which are the combinations that can be super key. Now write email ID, employee ID, first name, last name, hire date, department ID, all of the columns together. Then also it can become a super key. Okay, so you understand the concept of super key, the combinations which can uniquely identify a row. So single employee ID can be a super key, single email ID can be a super key, combination with employee ID and email ID can be a super key, and combination of all of them can also be a super key. Okay, now candidate key. Candidate key is minimal of super key. Minimal of super key. See, if I take the first one, employee ID, do you think that it can be a candidate key? Yes, because minimal of super key, only single column, and it can uniquely identify. Minimal of super key which can uniquely identify. That is the logic of candidate key. So this can be a candidate key also. This is a super key, this can be a candidate key also. Email ID, minimal of super key, it can identify. So this is also a candidate key. Now if I take this combination, employee ID and first name. So employee ID itself can uniquely identify. So it doesn't need first name. So it is not the minimal. It is not fulfilling that minimal condition. So it is not a candidate key. Got my point? Employee ID last name, same employee ID can uniquely identify. So this is not a candidate key. Employee ID salary, employee ID can uniquely identify. This is not a candidate key. Same way, employee ID hire date, not a candidate key. Not. And the combination of all things, that is also not possible. Okay, and email ID, employee ID combination, that is also not possible. So what are the possible candidates key? Only two. So we have got only email ID and employee ID. They are the minimal of super keys which can become candidate keys. Clear? First let me clear all these things, then I will tell you what is a primary key. Okay, just let me clear this. Okay, now fine. Now we have got our candidate keys. One is email ID, another one is employee ID. So you have candidates. Now you have to select who will be the winner. Okay, so you have to find which one is the best one who can uniquely identify the table. Now tell me, if I take email ID and if I take employee ID, which one is best suitable for primary ID? Tell me. Primary ID cannot have null, can never have duplicates. So employee ID can be null. No, every employee must have an employee ID. So this condition satisfies. Never have duplicates. Can employee ID have duplicates? Two people having same employee ID? No, that is also not possible. So this condition also satisfied. So this is ready for becoming a primary key. Now tell me about email ID. Can email ID have null value? It can have, because it may seem that in this world everyone should have an email ID, but it is possible that anybody can say I don't have an email ID. Okay, maybe that person doesn't have any personal email ID. So it can be nullable, right? But duplicates, no, they don't have duplicates. Okay, but one condition is actually failing here. So if you check among these two, you will think that employee ID is best suitable. Fine. Now I imagine that it is not nullable. Everyone has an employee ID. So sorry, everyone has an email ID. So in both cases, it also satisfied, it also satisfying. So how to select? So now you have to give some preferences, like which one is more simple, which one is numeric. Numerical numbers are easy. or which one is more suitable for foreign key. As you have no idea about foreign key, I am not going to explain it here, I'll connect it later. But see, you have to prefer over all these conditions. Okay, so you can find which one is best suitable. Now tell me, which one is more simple or which one is numeric? Employee ID, the high chances of becoming numeric. Email ID, no, because normally people doesn't use numerics for email ID. So here employee ID gets again. Simple also employee ID, because they will always follow a particular format. Whatever the format is, they will follow a particular format. But email ID, anybody can create any types of email ID. So in simplicity also employee ID is one step ahead. Considering this scenario, we can decide that employee ID is the best suitable for candidate key. Clear? So all the combinations which can uniquely identify a row is a super key. Only minimal of super key which is enough to identify any particular row, that is candidate key. And among the candidate keys, which one is the best for uniquely identifying a row, that is known as primary key. Clear? Now the next question. Alternate key. What is an alternate key? See, we have chosen that employee ID is going to be the primary key. So who is the second best? Email ID. So email ID is the alternate key. So we can say alternate key is that candidate key which is not the primary key. Among the candidates key which cannot become the primary key is the alternate key. Okay, so email ID is the alternate key here. That must be a candidate key but not a primary key. Clear? Next one is composite key. Composite key is that primary key which is made of two keys. You are lucky you have got employee ID here. But in some table you may face a problem that not any particular column is capable of uniquely identifies a key. So in that scenario you have to use composite key. Let me first give you an example. Let's say I have a table student taking enrollment in different courses. So there is student ID, they have taken enrollment in course ID and enrollment date. Now if I tell you student 1 have taken Java 12 February. Now student 2 taken SQL 12 February. Now student 1 again taken SQL 13 February. Now student 4 has taken Java in 14 February. Now if I question you that can student ID become a primary key? No, you can see that there are repetitions, so it cannot uniquely identify any row. It cannot become a primary key. Course ID can become a primary key. See, repetitions, so it also cannot become a primary key. Enrollment date can be, no, in a same date multiple enrollment can happen, so it can also not become a primary key. So in that scenario, you have to take help of two columns together, student ID and column ID. So if you take the combination, first student Java, fourth student Java, second student SQL, first student SQL. So if you take the combination, then it will become unique. Okay, right? So in that case, you have to take student ID and course ID combination. This combination will help you to create a primary key, right? So in these types of scenario, you call them composite key, because both of them are required to create the primary key. Clear? Okay, so the next one is foreign key. Let me first copy this one and paste it here, and let me create one more table. Foreign key means you have to make a connection between two tables, more than one. So I have to write department ID, and I can write department name or total number of employees, whatever. Just check. This is the employee table, this is the department table. Okay, now tell me which one is the primary key for the department table. Which one is the best suitable? Department ID is the best suitable, right? So this is the primary key of this table. And now if I ask you that make a join between employee table and department table, okay, for fetching some data. How can you make the join? By using a common column. So which is the common one? Department ID and department ID, right? So they have same column, department ID. So these types of keys are known as foreign key. So the definition is foreign key means a field of one table which uniquely identifies the rows of another table. Clear? So here it is a single field, a single column, but that is the primary key of another table. Clear? So we can write department ID is the foreign key of employee table. Fine. I hope all the keys are very clear to you. Let me give you a small recap. Super key is a combination of columns that uniquely identifies a row in a table. So it can be multiple super keys. Candidate key, minimal of super key. Okay. Primary key is candidate key, which is the best one. Alternate, which is the second one, who remains. Composite key, when you are using more than one keys to make a primary key. One is not enough. So it's like you need more people. Composite key. Foreign keys, in your table it is just a field, but for other table this is the primary key and helps you to make a connection, that is known as foreign key. Okay, so I hope I am able to make you understand the differences between these keys. These are very important because while creating a table all these things you have to keep in mind so that you can build a good database. Okay, so bye, happy learning. Well, today we are going to learn about constants in a database. Okay, first we will learn what is a constant, then why it is used and what are the types. Then we will create a table applying those constants. Okay, so let's start. What is the definition? Constant is nothing but set of rules that must be met while inserting a value inside the database, updating a value in the database, and deleting any value from the database. So these rules must be met while working with the database. That is known as constant. But why? Think that in your age column I am putting some values 150, 170, 190. Do you think that it is valid? No. So there is data inconsistency. In the roll number column I am putting null value. Do you think it is possible? No. I am putting duplicates. Do you think it is possible? Same roll number, two student? No, that is also not possible. Let's say in employee ID column, I am putting null values. Do you think that it is possible? No. So this kind of data inconsistency can be avoided by putting some constants while doing these things in a database. Clear? Now what are the types? First is not null. Let me give you an example. Take this one, roll number. Can it be a null value? No. Employee ID. Can it be a null value? No. So in this scenario, you can apply this not null constant. It means that the rows can never be null. So you insert them as null. No, it is not possible. You are updating them as null. Not possible. You are deleting that particular column. You are deleting only the roll number from that particular row. That is also not possible. Okay. So you understand what is the purpose of constant. Now the next one is unique. Tell me, can roll number be duplicates? No. Can employee ID be duplicates? No. So in this scenario, you can write that these rows can never be duplicates. If I add email ID, do you think an email ID be duplicates? No. So you can say email ID cannot be duplicate. So you can put this unique constant to these particular columns. Okay, right. So this means these columns can never have duplicates. So you cannot insert them duplicates, you cannot delete, you cannot update, you just have to keep it in mind that these things can never be duplicates. Okay, you cannot make any duplicate entry. The third one is primary key. You know what is a primary key? Primary key means primary key means by which you can uniquely identify any particular row, right? So it can never be null, it can never be unique. So employee ID, roll number, these things can be a primary key because it cannot be null, it cannot have duplicates, and by using employee ID you can uniquely identify any employee. If I tell any employee ID, there will be only one employee for that, right? So this is a primary key. So you can put primary key constant on a particular column. Next, we have foreign key. What is a foreign key? Foreign key means a non-key of any column but primary key of another column. Let's say we have two tables, employee table, department table. So in department table you have department ID department name. So department ID is the primary key. You can easily say by using department ID you can uniquely identify any department, right? But in employee table you have ID, name, age, department ID. So here department ID is a non-key. It is not any key. Okay. So non-key of employee table but a primary key of another table. Whenever you are making any connection between them, you can use this particular common column. So it is a primary key of department table but a non-key of employee table. So we can say department ID can be a foreign key of employee table. Right. So this also can be a constant. So you can put that department ID is a foreign key. Okay. This also can be a constant. Now the next constant is check. If I'm so sorry, let me delete this. Write it again. Next constant is check. Let's say in your age column, in this age column, I put a value called 190. Is it possible? No. So you can give a check that please ensure that age is greater than 25, less than 75. Or let's say there is a column called salary. You put salary greater than 10,000. Whatever constant you want to provide, you can apply using check column. Clear? Next is default. If you forget to make an entry, you can set this default. So if you just miss it by any chance, there will be a default entry. Okay. So these are the constant you can apply. First one is not null, unique, not null, can never be null, unique can never have duplicates, primary key, uniquely identify any particular row, foreign key, non-key of any table but primary key of another table, check for applying any check, and default for if you provide nothing. Okay. Now I will give you two tables and I will ask you that what are the constants you will apply when creating those tables. Same table or favorite employee and department table. So department ID, department name, this we have ID, email, name, salary, department ID. Okay. Now tell me, for the ID column, what are the constants you can apply? Our first constant is not null. So can we apply not null here? Obviously, ID can never be null, so we can apply not null. Second, unique. Can it be unique? Obviously, employee ID will be unique. People cannot share same employee ID, right? Primary key, can it be a primary key? Yes, it is a very good candidate for becoming a primary key. But once you make it a primary key, do you need to apply this constant? No, not exactly. Because primary key itself says that it must be unique and it must not be null. So you can simply delete and you can apply primary key constant. Clear? So this is the way you will declare any constant. Foreign key? No, it is not a foreign key. Check, if you want, you can apply some check like it must be of 6 digits or something. Or default, if you want, you can provide default also. One more thing you can do, that is auto increment. If you provide auto increment, then it will be automatically incremental. So first one will be 2, second one will be 3. Okay, that thing you can do. Let me clear it. Okay, clear. Now tell me about email ID. Can it be not null? Let's say some employees may not have email ID. So I am not putting that constant. Unique? Yes, obviously. Email ID will be always unique. So you can put unique. Primary key? No. Foreign key? No. Check? You can provide some check like employee ID must be @gmail.com. Okay, you want only the Gmail ID. So you can put that check. Default? If you want, you can give, but I will suggest no. Why should you give any default? Name. Tell me, can it be null? No, so you will put not null. Can it be unique? Never. Any two people can have the same name, so it will never be unique. Primary key? No. Foreign key? No. Check. If you want, you can put some check. Or default? No. Salary? Not null. Obviously, so everyone will have some salary, so you can give not null. Unique? No. Salary can never be unique. Many people can get the same salary, so it's not unique. Primary key? No. Foreign key? No. Check. You can put some check like salary greater than 10,000. Default? No. In department ID, can it be not null? No, everyone should be posted to some department, so it can never be null. So we can write it is a not null. Unique? No, many people can work in the same department, so it will not be unique. Primary key? No. Foreign key? No. check. No. Default? No. Okay. Now in this table, department ID, obviously primary key. Once it is primary key, you don't need to put not null or unique. Okay. In department name, can it be null? No, it cannot be null. There must be some department name for every department ID. So you will write not null. Unique? No, you don't need to provide unique because you don't need to do that. Primary key? No. Foreign key? No. Okay. Now tell me, in this column there is a department ID. In this column there is a department ID. So if you make a connection, you have to use this department ID column. Department ID is the primary key of the department table and department ID is the non-key of employee table. So department ID will be a foreign key of employee table. Okay, clear? So these are the constants we can apply. Now I will open MySQL. I will create these two tables and I will show you how this works. So let me open MySQL workbench. Okay, now first create a database. So create database our company. These are the DDL commands. I hope you know. First we have to create a database. What happened? Oh, sorry. Mm, don't give any space. Okay, fine. Now use our company. Inside this our company database, we will create table. Okay, so whatever the tables will be created, those will be created inside this particular database. Our company database is created. Okay, now we will first create a table without any constant. So our first table, create table, sorry, table name, let's give employee. Now we will give ID, integer, email, varchar 100, salary, decimal 10 comma 2, and we have department ID, integer. Okay, so first let me run this table. So sorry, first let me run this statement. Okay, our table is created. If we click here, let me first refresh this. If I create a table, sorry, if we click here, employee table is created. Okay, click here, ID, email, salary, department ID. Perfect. Now we will create constant. Okay, see, if I insert, sorry, into employee ID, let's say 1, email ID, let's say I provide whatever, salary I provide 10, department ID I provide 0. See, whatever I want to apply here, if I just click it here, what happened? ID, email, insert into employee, values. Okay, now if I run this, see what happens. This will be inserted. So ID, email, salary, department ID, all these things have been inserted. But if I copy this, see, if I put 0 here, then see, inserted. Now if I put null here, now see, if I run this, still inserted. Get my point? Whatever we insert, this is getting inserted, but that's not what we want. So we will put some constants here. Now how to apply those constants? First let me delete this table. Otherwise if I create table once again, then it will show me an error. So now I will show you how to put constant. So here let's say ID I want to make primary key, so I will write primary key, comma. Now if I create this table once again, see, the table is created. So let me refresh. If I sorry, there is a syntax error, so we have to delete this. Okay, now let me run this. See, now your employee table is created. Here I have created ID as primary key. Okay, now I will show you while inserting the first value. This one, let's say I insert it. Now in the second value I again put 1, the same ID. Do you think it will be inserted? What do you think? No, there will be an error because it will show you duplicate entry for 1. Once you have given primary key, so it will never let you insert the same ID for 2 employees. But if I simply change it, now let me insert this, insert it. Perfect. Now tell me, what about this one? Do you think that this will be inserted or not? What do you think? If I run this, there will be an error because it cannot be null. Primary key can never be null. It cannot be null. It cannot be duplicate. Clear? So we have learned how to add primary key. Now in the email column, let me write it in second. In the email column, what do you think that constant we can apply? Unique. Email will always be unique. So we just write email as unique. Okay. Now if I tell you that give the same email ID. So let's say email ID is a@gmail.com. Okay. Now let me copy this. Okay, here also you have to make changes. 1 2 is already there, so I will give 3. I put this, make it 4, and the same employee ID. Okay, first let me insert this same employee ID, and here I am putting the same email ID. Okay, I have changed the employee ID, so there will be no error for ID, but there will be a problem for email, right? Because I am putting the same email and I have given that unique constant. So let me run this. See, there is no error. Why is that so? Let me show you that in this table, refresh this employee table. If I click here, see, in both cases, email ID is a@gmail.com. Okay, because we have not applied this. So first I will drop this. Now everything is deleted. So now I will once again create the employee with this unique constant. Now if I run this, I'm sorry. Now if we run this is inserted because the first time, let me show you the employee value. See, a@gmail.com, first entry, so it is done. But if I make the same entry for this one, so here the ID is 3, so employee ID fine, but email ID is same. Now if I run this, see, there will be an error because there is a duplicate entry. Clear? So for unique constant you have to give different email ID. Fine. Now let's say for salary. For salary, I can give a check constant. I can write check salary greater than 10,000. Okay. Now if I try to insert this, okay, first I have to drop the table. So let me drop the table. Let me run it again. Then a new table will be created with the constants, and I have provided a salary check. Now I will insert this value for a@gmail.com, and let's say I give 10,000. Okay, now if I run this, see, it is fine. But if I write 10, but let me change it here because I can't give it duplicates. This is primary key. Email ID also I have to change because this is unique. Now here I put only 100, but my constant is that salary must be greater than 10,000. Now if I run this, see, there is a problem. Check constant is failed. Clear? Okay. Now let's give something for department ID. For department ID is the foreign key, right? For department table. So first we have to create the department table. So let's create one more table. Create table department. Here I will create department ID integer, comma, department name. Department name is varchar 100. Okay, fine. So let's see. Let me run this. Department table is created. Okay, now put some constant here and put some values in the department table. So we can put some constant. How? For department ID we can create this as primary key. So we can write this as primary key. For department name we can say this is unique, right? Department or not null, we can write not null. Okay, so now if I run this, sorry, table department is already exist. So what you have to do, first you have to delete this table because you are trying to replace, so that is why you have to just simply delete this and now run it. Okay, now it is created. Now let's say if I put some values, insert into department, if I put 1 comma department name as, let's say, finance, Okay. Now tell me, will there be any problem? I'm sorry, values. Now tell me, will there be any problem? What do you think? Will it be inserted or there will be any problem? No problem. Why there should be any problem? Let's say I uh, I put one more value, that is this one. So I write 2. Now if I want to insert this, no problem. But if I write 1, then if I try to put, there will be a problem because duplicate entry, you have set it as primary key. So you can see that how constant is working. Now for department name you have given not null, so check with that also. Let's say I'm giving it, change it, so I'm giving it 2, let's say give it 3, and here I am giving it as null. Can you tell me, will there be any problem or not? No, there will be no problem. See why? See, it is inserted. Why? Because here null doesn't mean null. Here null is a string. I have given it in quotation, so don't make that mistake. But if I write it in this way, so I have to change this. Let's say 4. Now if I run this, see, there is a problem. Now it is saying that it cannot be null. Okay, so don't make that kind of mistake. So here also the department table is created. Fine. So let's refresh this. Check both of the tables. Department table. This is the department table. 1, 2, 3 department ID. In the employee table, we have the employee ID table. Okay. Now let's say I want to create the foreign key constant. Okay. So for the foreign key constant, we have to create this table. So we have created this table. Now we will see that department ID is the primary key of the department table. So department ID will be the foreign key of the department, sorry, employee table. Okay. So now we can write foreign key. The key word is foreign key. Which column? Department ID column. So write department ID. Referencing to which particular table? It is referencing. So references is the keyword. References department table of department ID column. Okay, understand. Foreign key is the keyword. Department ID is this column. That this non-key column is referencing to which table? Department table. Department table is a different table and department ID is the primary key of that table. Okay, so you are giving foreign key, your column name, referencing to which table, what is the column name of that particular table, and that particular column name must be a primary key of that table. Clear? This is how you set foreign key. So first I have to delete this. So sorry, first I have to delete this, otherwise it will show an error. Now I'll again run this. Clear? Now a department ID has become the foreign key of department table. Okay, now let's say I put some values into employee table. So I am putting insert. Let me delete this all. Now I am putting some values in the department in employee table. So I am putting ID as 1. This is the email ID. This is the salary. I have to give some better salary. And department ID, I am putting what are the values here. See, 1, 2, 3. So it will reference. So you have to write, let's say 2. Now if I try to insert, what do you think the output will be? See, it is inserted. So if I let me refresh this. If I click the employee table, department ID 2, and department ID 2 means it is referencing to finance department. Okay. Now if I write 4, now what do you think the output will be? Let me change this. Now tell me, what will be the output? Will it be an error or it will be inserted? See, there will be an error. The error is due to some other reason. Okay. Now delete me this one. Now see the error. Cannot update a child row because the foreign key constant failed. I am giving something 4 as department ID, but in department table there is nothing called 4, so it is unable to find. So how will it create the differences? So that is why it is facing a problem. Now if I give here, let's say sales, so let me insert this value into department table. Now let me create. let me execute this one. See, now it is inserted. Clear? So it is referencing to department table. So if it is not existing in department table, how will it create the difference? So that is why it was showing an error. Now the problem is solved. So okay, now we will create one more table to show you how to apply constant in a different way. So if I write create table department, now I write department ID as integer, department name as varchar 100, and now I will put the constant. Okay, so I can put it in this way also at the end. So at the end I will write constant. Constant is the keyword. Now you give some name, the naming convention pk department ID. I will give department ID as primary key. So I can write primary key for which column? Department ID. Okay, it means please make department ID as primary key. Okay, so constant keyword. This is the name of the constant. What is the constant you want to apply? On which particular column? Clear? Now you tell me for department name, let's say I want to give that it cannot be null. So I want to write constant, give a name. So I can write unique department name. I will create unique column, unique constant. So I will write constant unique. Now on which column? Department name. Clear? So this is the way you can declare. If you want, you can add some more constant. Let's say I want to give that the department name must be HR, finance, IT, marketing. Okay, so I can write constant check department name. This is the name you are just providing, and here I want to check, so I will give check constant. So check. Now check is, what is the check here? Department name in is operator that we will learn while learning DQL. Here you can write HR, finance. Let's say you have only two departments, so HR and finance. Okay, so this is the way also you can give. Fine. Constant name, the constant you want to apply on which particular column. Constant name, which constant you want to apply on which particular column. Same way, put a comma. Okay, so this is the way you can create constants also. Let me show you. Let me run this. If I refresh, see one department column is department table is created. Okay, so in this way also you can put constant after that particular column, or at the end also you can put constant. Whatever you feel that is easy, you can follow this. Fine. Okay, now we are going to learn how a database should behave when a reference row in the parent table is deleted or updated. Simply, my question is, we have two tables, department table, employee table. So if I delete something from department table, that particular corresponding row will be deleted from the employee table, will remain in the employee table, or will throw an error. Okay, so what will happen? That is the question. So these are the things which can happen. That's what we are going to learn. We will take all these cases and we will see how it works. So first I have created a department table. So let me just run it. Department table is created. Same department ID, department name. Employee table is created. Employee ID, employee name, department ID, foreign key. Okay, and here see I have written on delete cascade. What does it mean? That we will see. First we will insert some values in the department table. So I have inserted. Let me refresh this department table. Let me show you the table. HR IT. Okay, fine. Now insert some values into the employee table. So let me run this. So Alice is in first department, that is Alice is in HR department, Bob is in IT department. Okay, this is the department ID and this is the corresponding department name. Perfect. Let me show you in employee table. Alice is in department ID 1, Bob is in department ID 2. Okay. Now my question is, if I delete HR department from department table, then what will happen in this employee cascade table? That is the question. So I have written a query to delete from the department table where department id equals to 1. So I am deleting that department, that HR department. So if I execute this, see, it is deleted. Now the question is, what happened to Alice then? So let's see. Let me click here. See, Alice is also deleted. Clear? So automatically, I have not deleted Alice from employee table. I have deleted from HR table. But automatically, Alice is also deleted. Okay, so on delete cascade means whatever happens in department table also happens in employee table. Clear? Now the second, we are going to learn about on delete set null. Okay. Now see, in department one, first department is deleted, so that's why I have again inserted this. So let me insert this. So now I have HR IT. Fine. Okay. So in the employee table, now I have set on delete set null. Only these things I have changed. All other things are same. Earlier it was on delete cascade, now on delete set null. Fine. Now I am inserting two values into the employee table. So, what happened? Okay, sorry, I have not created the table. Let me create this table. It is created. Now I am going to insert these values. Okay, so let me show you. Refresh this. If I click on delete cascade, oh sorry, on delete set null, then you have Charlie and David. Okay, Charlie is in HR and David is in the second department, which is IT. Okay, fine. Now I will check. If I delete from the department table, then what will happen in employee table? Because I have set on delete set null. See, if I delete this, it is executed. So now see what happened in employee set null. See, this has been set as null. Earlier that row was deleted, but now David is there. David is not deleted. Employee ID is not deleted. Name is not deleted. But the department ID has been set to null because that department is not existing in the department table anymore. Okay. So I am deleting information from the department table. But the corresponding table but the child table, that is the employee table, is getting affected in different way. Okay. Now the next one. Create employee table with on delete restrict. Same way, I just have to insert the values again. Let me copy this because I have deleted that. So just okay. What happened? Okay, it is there already then. HR is there. Sorry. That one was deleted. So I have to write to IT. Okay. Okay. Now I will create this table employee restrict. Same thing, just here I have written on delete restrict. Okay. Now insert the values in this table. Values are inserted. Emma is in HR department, Frank is in IT department. Okay. Now I am again deleting Emma. So I am not deleting Emma. I am deleting the department ID 1. So I am deleting the HR department. The same thing. So I have deleted. But see, cannot delete or update a parent row. So here it is showing an error because I have put on delete restrict. So that is why it is restricting you. So on delete means whenever you are trying to delete, it will restrict you. Clear? Now the fourth one. On delete no action. See now what happens. So I have to again insert the values. Okay, it is not deleted, so I don't have to insert. Fine. So I will run this. Now this table is created, employee no action. All the things are same, but I have written on delete no action. Okay, I am again inserting two values into the table. Okay, now see the department table, HR and IT department. And now I am trying to delete the HR department. See, if the employee exists, there is an employee called Grace, so it is showing as an error. Okay, so you understand what are the things that can happen while you delete something from the parent table and that is related to some child table. Okay, clear. Now we are going to learn two more things. One is add constant and delete constant. Okay, you have created a table and you have created constant. Now suppose you want to make some changes in constant, or you want to add some new column with some constant. So what will you do? See, this is the employee table. So let me run this table first. What happened? Failed to open the reference. Okay, first I have to create the department table. Okay, now I am creating the employee table. Okay, now it is fine. Now my question is that I want to add one more column in the employee table, that is age column. Tell me how can I do this? So you know DDL command, alter table, table name, right? Alter table, table name. Now add column, column name. I want to give age. Age, you have to tell the data type now. So age will be integer. Now you have to give the constant. What is the constant for age? The constant is, I want to give check constant age greater than 25. Okay, so I want to add one more column, that is age, and here age will be always greater than, not less than, always greater than 25. Okay, so now let me run this. See, it is done. Now if I insert any value, insert into table name is employee values, here I will put id, that is 1, employee @gmail.com, and salary, let's say 10,000, as it will show an error, salary is greater than 10,000, department id, let's say 1, and now you are giving age. Let me show you the table first. Let me refresh this. See the employee table. See, this is the employee table. Your age column is added. Now I will give age as 20. What do you think? What do you think it will become? It will be an error. See, there is an error because it is not validated. So if I put 26 greater than 25, now if I, still there is a problem because foreign ID, okay, foreign ID department table, I have to check in department table. There is no value, that's why it is unable to update. So you have to insert some values in the department table. Okay, just give me 2 minutes. Insert table values, I'll put 1 for HR. Okay, so now let me run this. Value inserted. Now I can use it as reference. Clear? Okay, so you have to always keep it in mind whenever you are creating any table, any values in the child table, there should be some references in the parent table. Okay, so you have to be very careful while you are implementing foreign key. So the last one is deleting a constant. For that I have to create a table, create table order of employee. Now I put id integer and name, name of employee, which is varchar of 100, and now I will write a constant with a constant name. Without constant name you cannot delete, so unique underscore name. Now my constant is unique, I'll put this on name of employee. Okay, now let me run this. So a table will be created with this name. Now I will drop the constant name of employee. This constant I want to delete. So alter table order of employee, drop constant, and constant name is name, sorry, constant name is the name of the constant, so you have to give unique name. Okay, so this name is required, so that is why you have to create the constant in this way only. If you write just after this one, after the column name, then it will, you cannot delete this, so you have to follow this rule to drop. Okay, so we have understood everything related to constant in a database. Now you practice a lot, and one more thing I will ask you to do, that I have done this for on delete, you also apply it for on update. Okay, same thing, you just have to write on delete cascade, on update cascade, on delete set null, on update set null, and then try to update the table, then see what is the output. Okay, so bye, happy learning. Today we are going to learn about DQL, data query language. We know how to create a table using DDL commands and how to insert values inside the table using DML command. So now we are going to fetch data from the database using DQL commands. So today we are going to learn about select clause, from clause, and where clause. Okay, so first let me create this. First you have to create a database. So let me create this database. Then we are going to use the database. Inside the database, we are going to create this table. One is department table, department ID and department name. Another one is employee table. There you have employee ID, name, age, salary and foreign key department ID. So now we will insert values using DML commands. So in department table, we have inserted values. Now we are going to insert values in employee table. So we have, now the values are inserted. Okay. Now we are going to learn how to write queries. Let me show you the table. Just let me refresh it here. So if I click, two tables, department table, employee table. Clear? Now my question is, please fetch all the name from the employee table. Okay. So how to write the query? So first you have to use the select clause. Select. What do you want to select? I said name. Select name. From where? From the table name. The table name is employee. Now if I execute this, see what is the result. Okay, all the names are selected. Clear? Okay, now we have learned how to fetch a single column. But if my question is how to select employee ID and name both from the employee table, then you have to write select employee ID from employee table. See, if I execute this, see, you can see the employee ID, but I want employee ID and name also. So, comma name. Now you can see what happened. Sorry, employee ID and name. Clear? So you can select employee ID name. So by putting comma, you can select multiple columns from using a single query. Now I want to see all the columns. So will you write like this? Select employee ID, comma name, comma age, comma salary, comma department ID. No, you don't need to do that. So we can write select star from employee. Now if I execute this, see the complete table is fetched. Okay. Same way, if we write select star from department. So all the values from the department will be fetched. Okay, clear? Okay, now we are going to learn about as keyword. Let's say when I am selecting all the names, I want the column name to be name of the employees, not only name. Okay, so I can write select name as name of the employees from employee. Okay, so it is always better if you write in capital. Okay, so now see, if I run this, see the column name has been changed. This is the name, but the column name has been changed. So by using the as keyword, you can give a name as per your choice. Okay, now we are going to understand about where clause. Where clause means when you will put some condition. Okay, now let's say my query is I want the name of those employees where salary is greater than 50,000. Okay, so you understand, I am putting a condition. Whenever you put a condition, you have to use the where clause. So you have to write select. What do you want to select? Name. From which table? Employee. Now I am putting a condition where what? Salary greater than 50,000. Okay, now if I run this, see Alice, Bob, David. Now if you want to see their salary also, then you have to write name comma salary. So it will give you name and salary. I think everyone's salary is greater than 50,000. Okay, so we can make like let's say 90,000. Then Alice and Bob will not come. So I'm putting it 90,000. No one salary is greater than 90,000. So let's give 70,000. And I think we can get some value. Okay, Bob, David, Ian. Okay, so this way you can filter your data. You are putting some condition using the where clause. Okay, or if you want, you can do something else also. Let me show you the table. So you can you can check that only name of those employees who have age greater than 26. Okay, so for that what will be the query? So you have to write select name comma, I want to see the age also, from employee table where age is greater than 26. See, they are all greater than 26. Okay, if you want greater than 30, then Alice will be removed. So you just have to write 30. Okay, now where clause can be used for updating also. Update using where clause. Okay, let's say in employee table, I want to update Bob's salary. I want to make it 90,000. Okay, so for updating Bob's salary also I can use the where clause. Let me show you. I have to write update on which table? Employees. What do you want to update? I want to set. Update always comes with set. So update set. Now which column? Salary. Set what? I want to make the salary 90,000. So I am setting salary as 90,000. For whom? So here you have to give the condition. The condition is not for everyone but for Bob only. So where name equals to Bob. Now see, if I run this, I think it's done. If I want to check Bob's salary, so I can write select. How can I check Bob's salary? I can write select salary from employee where name condition is Bob, because I want to see only Bob's salary. So I can write name equal to Bob. Okay, so just let me run this. Bob's salary is not set, but why is that so? Oh, sorry, I have given wrong table name. Update employee, not employees. I'm really sorry for that. So now if I execute, I think now it's done. See, okay, so using where clause you can update somebody's salary, or you can update whatever you want to do. Let's say I want to update David's age. I want to make it 45, maybe for some reason. So I can just write set age equals to 45, where name equal to David, or you can say where employee ID equals to 104. Let me show you. In this way also you can change, where employee ID equals to 104. Now if I run this, so it's done. So if I want to check, select age from employee where I'm putting the same condition. So I'm putting where employee ID equals to 104. Okay, so see what is the age, 45. Clear? So in this way you can update. You can also delete by using the where clause. I want to delete someone's data. Let's say I want to delete the row of Eva. Okay, so I can write delete from which table? Employee. Delete from employee. What? So you have to put some condition where name equals to Eva. This is a string, so you have to write in this way. Delete from table where condition. Okay, so I think it's done. Delete from employee, want to affected. So if I want to now check, select name from employee, you can see that Eva is not present anymore. See, Charlie, David, Frank. Okay, while giving some condition you have to use where clause. Using where clause you can fetch data, you can update data, or you can delete data. Okay, so today we have learned how to use select clause, how to use from clause, and how to use where clause. Okay, bye, happy learning. Today we are going to learn about how to sort a data. For that we have to use a keyword called order. Okay, so we will learn how to do ordering in ascending manner or in descending manner. Okay, so we have two tables. One is department table, department ID, department name. Another one is employee table, employee ID, name, age, salary, department ID. Okay, so my first question is how to sort the employee name by salary column. I want to see who gets the minimum salary, who gets the maximum salary, and what is the order. Okay, so we are simply going to use the order by clause. So we have to write order employees by salary. So you have to write select. I want to see what? I want to see the name and I want to see their salary. Okay, so I have written select name comma salary. From table name you have to provide employees. Sorry, employee. Now you have to use the order by clause. So I will write order by. Order by which column? I want to order by the salary column. So you have to write salary. Now I want to see who gets the maximum. So I want to sort in descending manner. So I have to write DESC. Okay, you understand the keyword? Select for selecting, from the table, order by for ordering, by which column you have to mention the name of the column, and then in which order, in descending manner or in ascending manner. So let me first show you. See, Bob is getting the 90,000 salary, David is also getting 90,000, Ian is getting 88, 70, 62. You can understand that it is sorted in a descending manner. Now I want to see this same thing but in ascending manner. So Grace will be on the top and Bob will be on the in the end. Okay, so you just simply have to write ASC. Okay, ASC is for ascending, DSC is for descending. See, now Grace is on the top, 48,000 salary is on the top and David is on the end. Okay, you can see that it is sorted in ascending manner. Clear? Now order employees by salary in descending, that we have already done. Order employees by department and salary. So now tell me how to do this. I want to select, let's say I want to select everything, not only name and salary. So I can write start from employee. Now department and salary. So I will write order by department. What is the column name for department? There is only one column for department ID. Okay, so we can simply write department ID. No problem. Department ID in ascending manner, then salary in ascending manner. Okay, so you can order by using two column also. See. Now you have selected all, so start, that's why every column is showing. Now see the sorting is done using department ID 1 1 2 2 3 3 4 4 5. See, then it is done in salary. So 60,000, 70,000, 48,000. Okay, so the first order is done as per the department ID. So department ID, then it is done as per the salary. Clear? See, for first department 60,000, 70,000. Then for second department 48,000, 90,000. Then for third department 50,000, 62,000. For fourth department, so first it has given a preference to department ID, then the salary. Clear? Now next question is order employees by joining date, but we don't have any joining date, so leave this question for now. We have to add a column of join date, then only we can do this. Okay, let me close this. Now order employees alphabetically by name. So you have to do the order by on a string column. Okay, same, no problem. Select, I want to see the name only from the table name, and I want to order by which column? Name column, and alphabetically. So you want to sort in ascending manner. A will come first, then B, then C, in this way. Alice, Bob, Charlie, David. Okay, now if I want to see in opposite way, I want to see from Jack, then you just have to write descending. Simple, the same thing. Okay, now order departments by department name. Okay, so let me show you here. You have to use the department table. So order department by department name. Okay, so we will use select department from, the table name is department. I think department table, department name, sorry. So select department name from department, order by department name, and I want to do it in descending manner. Okay, so see, cells S, then M, then I, then H, then F. Okay, but if you want to do it in ascending manner, you have to write ASC. Now if, then H, then I. Clear? Order employees by experience. For that you need a join date column. I don't have that. Okay, so now let's do this one. Order employees by salary if equal, then by name. So first you have to give first preference to salary, then by name. So I can write select let's say I want to see everything. Star from employee. I want to order by salary in DSC manner. But if the salary is equal, then by name. So name ASC. Okay. So what will happen then? First it will sort as per the salary. But if both of them has same salary, then use the name in ascending order. See the output, you will understand. See, 90,000, 90,000. Bob also has 90,000 salary. David also has 90,000 salary. So how then second preference name? So that's why name is in ascending order. So Bob is first, David is second. But what if I want David as first and Bob as second? Because both of them has same salary. So I want to put David at the first. Then you just have to simply change here DESC. Now if you just run this. Oh, I'm so sorry. Now see, David comes first. Okay. So first priority is salary, second priority is name. Name you can put in ascending manner or in descending manner. Clear? Now the next one. Order employees with null values in the salary at the end. Okay. So you are going to order by salary, but you want the null values to come at the end, not in the first. Okay. So I can write select star from employee table. I want to order by salary is null, comma salary DSC. If I run this, see, there is an error. Okay, so you can say that there is no null value, so that's why. So first let me insert some null values. Okay, so that you can do by using update. Let's say I'll update employee table set salary equals to null for where employee ID equals to, let's say, 102. So for debit I am making the salary as null. I think it's done. Yeah, it's done. Okay, now if I run this, then you can see now salary, null salary is at the end. Okay, but if I write salary ASC, now let me run this. Now the salary is in ascending order, but the null value is at the end. So you put the salary in descending manner or in the ascending manner, the null values will be at the end. Clear? Okay. Now we are going to learn how to do sorting by a calculated field. First we will calculate a field, then we will do the sorting. Let's say I want to increase everyone's salaries by 3 times. So I can write select salary into 3 times as given name. So I can give 3 times salary. Okay, from employee table. Let me first show you what happens here. Everyone's salary is increased by 3 times. First, I have to give name also, then it will look better. See, everyone's salary is increased by 3 times. Bob's was a null, so it will always be null. Okay, now I want to order by on this calculated field. Okay, I have given a name by as keyword. So now if I order by, I can write order by on which column? This new column. It was not before, but I have given a name. So order by this. Now I can write ascending, descending in whatever you want. So just see, the null will be at the top. Now everyone's salary is in ascending manner. Okay, if you want you can write descending also, so it will be in descending manner. Okay, so this way you can put order by on some calculated field also. Okay, so today we have learned how to use order by clause, how to do order in ascending manner, and how to do order in descending manner. Okay, bye, happy learning. Today we are going to understand about operators in SQL. Operators are reserved word or keyword that is mainly used for doing different kind of operations. Comparisons, arithmetic. You can see that there are mainly 4 types of operators. Comparison, logical, negative operators and arithmetic operators. So we are going to create a table, then we will do all of this one by one with example. Okay, so first let me create this table. An employee table will be created. See, employees table is created. It has ID, name, age, department, salary, bonus, manager ID. Okay, let's insert some values. Insert it. Now we can see the table. Okay, now we will work with this table. Sorry, this one. Okay, now the first one is, let me show you. The first one is comparison operator. So we will see all of them: equal, non-equal, less than, greater than. Now find employees whose salary is exactly 60,000. So you have to find all the employees where salary is exactly 60,000. So you have to write select star from employee where condition you have to provide, because you can see that there is a condition where salary, so you can write exactly 60,000. So you have to give equal to. Equal to is the operator for equality, the first one, comparison operator. Okay, let me show you the output. mm, Select star from, sorry, employees. The table name is employees. Okay, so Bob has 60,000 salary. Fine. Now find employees whose salary is not 60,000. So same, select star from employees. Condition is where salary is not 60,000. So not equal to 60,000. So we can say this is non-equality operator. Okay, select star from employees where salary not equal to 60,000. See, no one's salary is 60,000. Okay, so select all the employees where salary is not equal to 60,000. Now find the employees who are older than 30. So select star from employees. Condition is age older than 30. That means greater than 30. So we will get all the employees who are greater than 30, 35, 40, 50. Okay. So find employees younger than 40. That means you have to select all the employees where age is less than 40. Okay, so this is less than operator. Hmm, sorry, I forgot to give where condition. Where age is less than 40. Okay, you can see everyone's age is less than 40. Clear? Now find employees who are at least 40-year-olds. That means 40 and greater than 40. So you have to use select star from employees where age greater than equal to 40. That means either 40 or greater than 40. Okay. Now select employees who are 30 years or younger. So I can write select star from employees where age less than equal to 30. So either they are 30 or they are less than 30. See, okay. So you have understood equals to, not equals to, greater than, less than, greater than, equal to, less than, equal to. These are all comparison operator. Okay, now we are going to understand the logical operator. See, find employees where bonus is null. See the table, we have to check where bonus is null. That means David. David will be our output. Okay, see how to write this. Select star from employees where bonus is null. Just you have to use this operator. See, David's bonus is null. Okay, so we have understood is null operator. Okay, clear. Now the question is find employees where bonus is not null. This is also same. Just let me copy this. Bonus is not null. Exactly same. You have to write is null or is not null. That means everyone will come other than David because they have some bonus. Okay, and David is not getting any bonus. Clear? Now between operator. Find employees whose age is between 30 and 40. So select star from employees where condition is age column between 30 and 40. Okay, let me show you. See, 35, 40, 30. Okay, Bob, Charlie, Eve, their ages, and you can see Alice 28, Eve, Frank 50. Okay, so that's why they are excluded. Clear? So you can understand the between operator, 30 and 40. Same, whose age is not between 30 and 40. Same here, you can just copy. You just have to write not. Okay, the keyword is between and here the keyword is not between. So that means all others 28, 25, 50, they are not between 30 and 40. Clear? Now find employees who work in the IT department or HR department. For that you have to use in and not in. Okay. See. Select star from employees where department, the name of the column is department. Okay, where department in IT or HR. So inside the bracket you write IT, comma HR. Okay, so select all the employees where department in IT and HR. Clear? See, all of them works either in HR department or in IT department. Here you can give some more also. So it will check if it is in IT department, HR department or in any other given department, then only show the employees. Okay. Now find employees who do not work in IT and HR department. So same way, you just have to write not in. They work in finance department. Okay. So you understand in operator, not in operator. Now the next question. Find employees whose name starts with A. So you have to write select star from employees where name like a person. Person is a wildcard character, that means anything after A. Starts with A and anything after A. So here we are using like operator. Okay. So like operator will check whether any name starts with A or not. See, Alice is starting with A. So that's why they have written Alice. Okay. Find employees whose name does not start with A. So we can write the same, but here we will write not. Not like a person. See, their name is not starting with A. Okay, so we have understood is null, between, in operator, not in operator, like operator, not like operator. Now we have this operator exist, all, some, any. For these operators, operators exist and all, some, any. You have to understand subquery. So as I have not explained subquery yet, I am not going to explain them. I will explain it later. Okay, while explaining subquery. Okay, now let's understand add or not operators. Find employees older than 30 and earning more than 50,000. See, here you are giving two conditions. One is employees older than 30, employees earning more than 50,000. If I give a single one, employees older than 30, then I can write select star from employees. You can try to tell where age greater than 30. This is for first condition. For second condition, earning more than 50,000. So for second one, select star from employees where salary greater than 50,000. Right? But they are single query. So you have to check both. They are greater than 30 and they are earning more than 50,000. So for this, you can simply delete this portion and you can write and salary greater than 50,000. Okay, so after where you are providing both the conditions together. See, age 35, salary greater than 50,000. Age 35, age 40, salary greater than 50,000. Age 50, okay, so you can see both of the conditions are satisfying. And operator is only applicable when the both conditions are satisfied. Okay, or operator is when any of the conditions satisfied. If I write find employees who are greater than 30, so I can write where age greater than 30 or salary greater than 50,000. If any of the condition satisfies, then only show us the result. See, here age is greater than 35, salary 60,000. Both the condition is satisfied. Age greater than 40, salary greater than 50,000. Here see, age is not greater than 30, right? But the salary is greater than 50,000. So David is also in the output. Okay. So you understand how it is working. Now the next one is find employees who are not in the HR department. So you have to write select star from employees where you just have to use the not keyword, not department equal to HR. Okay, so I'm saying the department is not HR. IT finance, IT finance. Okay, clear. So you are using not operator. Okay, so you have understood and or not operator. Okay, now negative operators. I have already told some of them. When salary is not equal to 60,000, right? Next one is not between. See, where age is not between 30 and 40. Next one is not in. See, a department not in IT or HR. Okay. Next one is not like, it's not starting with A. So not like a percent. Okay. And next is not null. Not null means show me the value where the data is not null. See, we have a null value here, manager ID. Okay. So let's write is not null. Select star from employees where manager ID is not null. Hmm. Sorry, manager ID, manager underscore ID is not null. See, manager ID, the first one, it was here. Alice had no manager ID, so here Alice is removed. Okay, this is not null. Now the next one is not exist. Now that also you have to know subquery. So while we will do the subquery, I will explain not exist. Now the last one is arithmetic operator. Addition, multiplication, subtraction and division. Okay. Find the total compensation. Salary plus bonus. Salary plus bonus. Okay. How to do this one? So select salary plus bonus from employees. Let me show you the output. See, it is added, but it is not looking good. We are not understanding whose salary is this. So you can write name comma salary plus bonus, and here we can rename this, by using as keyword. So we can write as total compensation. Okay, so we just want to see the total compensation. Okay, see, clear. So this way we can add. If you want to add directly any number like salary plus, I want to add 1000. Okay, so let me close this. Select salary plus 1000. So with every salary 1000 will be added. Okay, so we can do addition. Next, find the net salary after subtracting the bonus. So I can write select salary minus bonus, give a name net salary from employees table. Now let me show you. Okay, salary and you write name also. See, salary was 40,000, bonus was 5,000. So 40,000 minus 5,000, 35,000. Okay, clear. So this way also, or you can write salary minus 500. Any number also you can directly provide. Now find the increased salary after a 10% raise. So I can write select salary after a 10% raise mean you have to multiply with 1.1. Okay, because 110% right now your salary is. Select salary from employees table. Give some name first and you can give 10% rise. Okay, now write salary rise. Okay, so what happened? See, now see the salary 40,000. So if you raise a 10%, so it will be 44,000. See, it is 44,000. Okay, next one 60,000. 10% raise 66,000. Okay, clear. And the last one is dividing. So we can write, we have to calculate monthly salary by dividing annual salary by 12. So you can write select salary divided by 12 as monthly salary from table name. Okay, here also write name comma. Now if I execute this, What happened? Monthly salary. See, it is executed. So everyone's salary is divided by 12. Clear? So we have understood this also. Addition, multiplication, subtraction, division. Okay. Okay, so it is very clear to you what is operators and how these are helpful in SQL. Thank you. Bye. Happy learning. Today we are going to understand about some aggregate functions used in SQL. Okay, first let me create this employee table. Employee ID, first name, last name, salary, department, joining date. Okay, now I will put some values inside the table. Okay, now let me show you the table first. Okay, now our first query is calculate sum of all the salaries. See, this is the salary column. You have to calculate the total sum of the salary column. So we can write select sum of salary column from the table name. Okay, the sum function will calculate the total sum from the salary column. Fine. Now let me tell you about distinct. In this table you can see that there are people working in finance, HR, IT. Okay, so I want to know how many department is there in the company. Okay, so how can I write this query? For that you have to use distinct keyword. So I can write select distinct department from table name. Sorry, that is distinct. Okay, now let me show you the output. See, this is showing you the unique values finance, HR, IT. Total 3 types. So distinct keyword is used to retrieve unique values from a column. Okay, it eliminates the duplicates. If I ask you one more question, tell me, see here people have joined on 12th May, on 12th May, on 12th May and 5th January. So I want to know on which date people have joined. I want the unique values, not the duplicates. For that, you have to write select distinct joining date from employee. Now see, it will show you that on which date people have joined. So what happened? Again, distinct joining date. See, on these two dates people have joined. So no duplicates, only the unique values. For that you have to use distinct column. Okay. Now the next question, with distinct, sum of distinct salaries. Let's see the salary 55,000, 72,000, 45,000, and now there are 65,000. So for calculating distinct salary you have to write select sum. Sum function will calculate the sum. Now I am writing distinct salary from employee. See, now it is 23,7,000. If you calculate 55 plus 72 plus 45, so it will be, let me show you in calculator. Sorry for this big number. I can say 55,000 plus 72,000 plus 45,000 plus 65,000. Oh, sorry. See, 2,37,000. Now see the output, 2,37,000. Okay, so you can understand that 65, the second 65 is not calculated because it is duplicated. So it has taken all the unique salaries and then it has calculated the sum. Clear? Now the next question is count of all the employees. How many employees are working in the organization? For that you have to write select count first name from employee. If you count their name, then you can tell that how many people are there in the company. Sorry, employee. Total 5. 1, 2, 3, 4, 5. Okay. So count function will count. Next, distinct count. Let's say I want to know how many types of salaries people are getting. Okay. So here it will calculate only the unique values, not the duplicate. Same, you have to use count function, but count on what? Count on distinct salary. So first it is calculating the distinct salaries. So first it is calculating 55,000, 72,000, 45,000, 65,000. It has 4 once you apply the distinct keyword. then you are doing the count, then you are applying the count function. So 1 2 3 4. Okay, clear? That is how it is working. So now you can see that distinct total type distinct salary, 4 types of salary people are getting. Okay, next one, maximum salary. You just have to use max function. Select max salary from employee. Okay, so it will give you the highest salary. 72,000 is the highest salary. Okay, now minimum salary. Select, same way you just have to use the minimum function. Min salary from employee table. So see, it will give you which is the minimum. 45,000 is the minimum. Okay, now average salary. I want to know what is the average salary of the company. So I can write select average salary from employee. On an average, people are getting 60,000. Okay, now I want to get the average of distinct salaries. Same, just you have to do select average function on distinct salaries. So first this distinct salary will only consider the distinct values. Then you are calculating the average from employee. Now if I run, okay, if you want you can check with the calculator. So these are the main aggregate functions: sum, count, max, mean, average. Okay, so bye, happy learning. Well, today we are going to understand some mathematical functions used in SQL. Okay, first let me run this query. It will use the company database. Okay, now we will create a table named employee. There we have employee ID, first name, last name, salary, department, joining date. Now we are going to insert some values inside the table. Okay, now let me show you the table. See, employee ID, first name, last name, salary, department, joining date. Okay, now we are going to learn some mathematical functions. Okay, the first question is absolute value of the salary. See here, you can see one salary is in negative form, but I want the absolute value, no positive or no negative sign. Okay, so for that you have to write select ABS of salary from table name. Okay, you just have to write absolute function ABS. Now see, all the salary is in absolute value, no positive or no negative sign. Or I can write name comma, then it will show you the name also. What happened? Sorry, to write first name. See now. Okay, one salary was on negative, Michael, but you can see that is also in absolute manner. Okay, perfect. Now round the salary to the nearest integer. So we can write select round salary comma 0 from employee. First let me show you the table. See here 0.50, 0.00, 0.75. Now you see the output that it will be rounded. Let me show you. Clear? Nearest integer. If I write salary comma 1, then see what happens. Only one value after point. Okay, clear? So you can round it to the nearest integer or you can round it as you required. For that you just have to use round function. Now square root of the salary. So we can write select, the function name is sqrt, salary from table name. Now see what happens. Root is calculated, but for negative number you cannot calculate root, so that's why it is in null. Now get the sign of the salary. So we can write select. I want to know who is getting in positive salary or negative salary. Though it looks absurd, nobody will get negative salary. Still, we can get the sign of salary column from employee. Now see, if I run this, see everyone is getting positive, but the last one Michael is getting negative salary. Okay. Now raise the salary to the power of 2. So select power salary to 2 from employee. If you want to make the power of 3, then you have to write salary comma 3. Okay. Now if you want you can rename also by using the as keyword. Okay. Now the next one. Ceiling of the salary. So round up to the nearest integer. See, select cell salary from employee. Okay, so this will make the selling of the salary. See, earlier it was 55,000,000.50, so it has become 55,000,000, 001. Okay, second one, see, 45,000.75. Now you can see 45001. Okay, so it is rounded up to the nearest integer. Now if you want, you can floor also, then it will round down. Now see, select floor salary from employee. Now what will be the output? Instead of 55001, it will be 55,000,000. Now let me run this. Select floor salary from employee. Okay, see now. Okay, 55,000,000. Take any other value like 45,000,000.75. See, 45,000,000. Okay, so to round up, you have to use ceiling CEIL. To floor, I mean to round down, you have to use floor. Okay, now say I want to know the exponent of the salary. So I can write select exp salary from employee. Now it is exponentially raised. Here it is showing out of range, but if you want to calculate, you can use this function. Now sign of the salary. Select sign salary from employee. If you want to calculate the sign value of any number, then you can write sign of salary. Okay, or you can, if you just, I show you, select sign of 0. Now see, sign of 0 means 0, so that is why sign of 0. Okay, cosine of salary. So select COS of salary from employee. Okay, now so let me show you the COS value. Okay, cos value. Now if I write cos of 0, then cos of 0 is 1, so that is why 1. Okay, clear. Same, the last one, tangent of salary. Select tan salary from employee. So it will be tan value of salary. If I write tan of 0, see, it will be 0. Okay, clear. So we have understood absolute function, ABS, round value, round, square root value, SQRT, sign value for getting positive sign or negative sign. To make any power, you have to use power function. For ceiling, CIL. For floor, you have to use floor function, exponent, exp, sine, cos, tan. Okay, so these are the mathematical functions which are used in SQL. Okay, bye, happy learning. Today we are going to learn about some character functions used in SQL. Okay, so first let me create the database. I'll create company database, then we will use the database. Now we will create a table, employee table, having employee ID, first name, last name, department, position, salary, hire date and performance score. Okay, now let's insert some values inside the table. Okay, it's done. Now I will insert this value also, because I'll show you some functions with this value. Okay, here you can see that there are some spaces. We will learn how to remove these spaces, that's why. Okay, now our first question is, I want you to show me the full name of the employee. See, if you write select star from employee, see how does the table look like. See, first name is separate, last name is separate, but I want to see their full name. Then how can you do this? For that you have to use concat function. So you have to write select, you just simple, you have to write the function name, and inside this, on which do you want to concat? First name. So I write first name, comma, with last name. Okay, from the table name. Sorry. Now let me show you. See, they have concatenated, but the problem is there is no space and it is not looking good. So to add a space, you can write, provide a space and comma. Okay, now let me show you. See, there is a space. In this way, you can add whatever you want inside this first name and last name column. Okay, fine. So this way you can concatenate. So you just have to use the concat function. Now let's say I want to know the length of the first name. So I can write select length first name from employee. So it will give me the first length of their name. See, the first one is John, 4 word. sorry, 4 letters, Jane 4 letters, Emily 5 letters, and then there is a space, so that is why it is taking 14 letters. Okay, so it will give you the length. Okay, now let's say I want to convert into uppercase. The first name will be in uppercase. So you just have to write the function name on which column from table name. Now see. Okay, clear. Let's say I want to convert in lowercase. Same way, select lower on which column, first name, last name, then from employee table. Then every character will be converted to lowercase. Okay. Now I want to remove the leading and trailing spaces. See, first let me show you the table again. Select star from employee. So see, there are spaces here. You can see there are some spaces in the front, there are some spaces after the name also. Okay, so this leading and trailing spaces will be removed by trim function. So you just have to write select trim on which column, first name from table name. Now let me show you. See, no spaces in the front, no spaces in trailing. Okay, now I want to see the first 3 characters of first name. For that you have to use the select substring function. Substring on which column, first name, starting from 1 ending 3 from employee. So this way you can do slicing. Slicing concept you know, you learnt in Python. You just take some slices. Okay, and there are spaces, that's why 2 spaces and J. Clear? Now I want to replace John with Mike. See, there is an employee called John. Here also we have John. So I just want to replace this John with Mike. See how it works. Select. You have to call the replace function. Now you have to write on which column, to whom, to by Mike. Okay. From employee table. Now see how it works. See, John replaced by Mike. Here also the John word has been replaced by Mike. Okay, so whenever you find John, just replace it with Mike. Okay. Now let's say I want to know the position of Doe in the last name. In which row it is in the last name column. So just write select I in steer. Which column? Last name. What do you want to find? Doe. Doe surname. Okay. So from employee table. So it will show you the position. Okay, let's say for something else. Let's say for Johnson. So you just have to change here. Johnson. Just select here. See, Johnson is in third position. So all others are not Johnson. Clear? Now, okay. Now, rtrim. Rtrim means you will remove the trailing spaces from right side. Trim we have learned for removing the leading spaces and trailing spaces. Now I want to remove it from the right side, not from the left side. So for that you have to write select rtrim. On which column? You have to mention that I want to remove first name from employee. See, there first let me show you. There is a problem with this first name column. Okay, I have given some spaces. So that spaces will be removed. But see, the left spaces is not removed yet. Okay. So for doing that, you have to use ldrim. So it will remove from left. L for left. First name from employee. Now see, the left spaces will be removed. Clear? So for removing left spaces, ldrim. For removing right spaces, rtrim. Now I want to print the name characters in reverse order. So you just have to write reverse column name from employee. Now see, all the characters will be printed in reverse order. Okay. Now if you want to know the ASCII value of the first character, so select ASCII first name from table name. 7474. Okay. ASCII value will be shown. Now let's say you want to concatenate first name and last name with a separator this. Okay. So how can you do this? You can write select concat ws. You want to concatenate first name and last name with this underscore. Now provide first name, last name from employee. Now run this. Sorry, I forgot to provide a comma here. Okay. Still, what happened? Unknown field for, oh sorry, the spelling mistake. First name. Okay, first name and last name will be concatenated with this underscore. Clear? Now, is null. Is null. Let's say I provide. Okay, for that, just let's see. Everyone's performance score is given. So I want to add one value where there is no performance score. So I can add one more value. I'll insert one more value with 0 performance, not 0, I will insert with null. Okay, let's make it 5, otherwise it will show an error. All others I have kept same, no issues. Now, okay, let me refresh this here. Table. Okay, see, performance score is null. Now what I want to do, I'll select is null performance score. No, sorry, there is no underscore. So performance score with 0 from employee. Now see what happens. It works in SQL Server, but I don't know why it is not working. Okay, I'll let you know about this function. It actually, if find anything null, then it converts the null value into 0. Okay, so in some places it works as is null, but in some places it works as if null. Okay, no problem. Okay, now the next one is coalesce function. Coalesce function returns the non-null first non-null value. Let me show you. Select coalesce. Now let me show where is a null value. Performance score is null value. So I will write performance score and with salary from employee. Let me show you first. Coalesce spelling COALESCE. Sorry. See here what happens. Let me show you this first. Here there you can see a null value in the last row. In fifth employee ID there is a null value for performance score, but you can see, let me fetch name also. First name. Now see salary performance score 85, 90, 75, 85. Okay, see 90, 85, 85, 75, this performance score is fine, but here it is null, so it has been replaced by salary. 75,000 is the salary. See, 75,000 is the salary. So coalesce function first checks if there is any null value, then it will replace with the values of some other column. So here I have mentioned that first check performance score. If you find a null value, then replace it with salary column. Okay, so that is why here the salary column is fetched, not null. Clear? Now the next one is, okay, so now the next one is LPAD. This is for padding from left side, from right side. Okay, I'll show you. Select LPAD of first name. I can write 5. Pad with any special character. Let's say with 0 from employee table. Let me show you. See, If any name is of 4 character, it is added with 0 so that it becomes 5 character. Next one become 5 character. This one is 5 character already, so nothing added. Here also you have spaces, so nothing added. Clear? So it will make all of them as 5 characters. And from the left side, that is why LPAD. Same thing will be done using right side. Let me copy this. Just you have to write RPAD and the same thing will happen. See, now the same thing but from the right side. Okay, so you can do this with any special character. Whatever, if I give this one, then it will be padded with this one. So just to ensure a certain amount of length, you can use these types. Clear? If you want to make it 10 characters, you have to give it 10. So that every name will be of 10 characters. Okay, you can count. These are all 10 characters. So LPAD means from left side padding, RPAD is right side padding. Okay, so we have discussed all the character functions. Hope you have loved the class. Thank you for subscribing. Bye. Happy learning. Today we are going to understand about a very important topic of SQL, that is group by and having clause. Sometimes while writing a query, you may need to create groups of your data. But why is that so? And then how to do that? So that is what we are going to learn today. First, let me give you an example. Let's say you have an employee table, and in your employee table there is ID column, name, age, city. Now, some employees are living in city 1. Okay. 2 is also living in city 1. The third employee is living in city 2. Another one living in city 2. Another one living in city 3. Another one living in city 1. Okay. Let's say this is the table. Now, my query is, for each city, give me the names of the employees. So, tell me the name of the employees who are living in city 1, the name of the employees who are living in city 2. Okay, so you are understanding the query. You have to give the city 1, city 2, city 3, and then you have to tell me who are the employees living in city 1. This is the name column. This is what your output is. Okay, so you can understand that here you are creating a group of city 1, a group of city 2, and a group of city 3. Okay, so for these types of query, you have to use group by. Clear? Now let's do some examples, then things will be more clear to you. So first, let me use this database. In the company database, we are going to create a employee table. Now we are going to insert some values in the table. Okay, that is done. Let me show you the table once. The same table, employee table, we have all these details. Okay, now our first query. Query to get the average salary per city. Average salary per city. So first let me show you. I want to know that for city 1, for city 2, and for city 3, what is the average salary? So you have to say here the average of salary. So tell me, how can you calculate this? Okay, think how it is working. First you have to create the groups. Okay, so for you have to create a group of city 1, city 2, city 3, right? Once you create this group, now you write everybody's salary. First employee salary, second employee salary, whoever is living in city 1. You are taking everyone's salary. Once you get everyone's salary, then you are applying the average function. That is the step. First you are creating groups, then you are taking the salaries of each group, then you are calculating the average. Clear? Now let's see how we write this query. So you have to write select. Now you have to tell the average salary. So you want to select city, comma, average function, you know, that will calculate the average of the salary column from employee. Now average salary per city. Okay, so you have to group as per the city. So you have to write group by city column. Group by city. Clear? Now let me show you. The table name, employee. See, this was our requirement. Okay, see, city, average salary. Clear? So this is the step what is happening in the background. First a group of cities, then you are taking everybody's salary, then you are calculating the average. And you have to write the query in this way. First you have to tell that I want to city, I want to see the city, I want to see the average of salary. That will be in our output. And from which table? And then you are creating a group of city. Group by city means you are creating a group of different cities. Okay. So whenever you get the part term, you can understand that you have to create a group of this one. Okay. And always keep it in mind that whatever column you are using for group by, you have to always keep that column here. Okay. Otherwise it will not be able to show the result. So don't make that mistake. Okay. Now let's do the next query. Query to count employees per city. Let me first tell you what I want to say. Query to count employees per city. So I want city 1, city 2, city 3. And you have to tell that how many people are living in city 1. Let's say 3 people. How many people are living in city 2? 2 people. How many people are living in city 3? 1 people. Okay, this will be our output. How to do this? First you have to create the group. Same city 1, city 2, city 3. You have to create the groups. Once you create the groups, now you can write their name or any other rows. Let's say name. So you are taking name of this one, name of this one, name of this one. Okay. Name or any other column. City column you have 2 name. In this column you have 1 name. So once you get that, then you will apply the count function. So now if I apply the count function on this one, then it will tell me this is 3. On this one it will tell me 2. On this one this will tell me 1. So I will get my final output. Clear? Now let me show you the query. So I will write select. I told you, you have to be very careful that I want to see employees per city. So the group by will be as per the city. I am creating a group of city. Clear? And what I want to see? I want to see the count. So I can write select city. City I have to use because I am grouping as per the city. So city will always be there. And you have to write count. Count you can do on any column. If you write star, then also it means that give me the count. Star means all. You know that. Now you have to write from which table? Group by city. Clear? Now let me execute this. Employee. Okay. See, New York, Los Angeles, Chicago. So 3 people are living in New York, 2 Los Angeles, 2 Chicago. Let me show you the database. See, New York 1, 2, 3, right? Los Angeles 1, 2. In Chicago 1, 2. Okay, that's what our output is. Clear? Now let's do the next one. Query to get the total salary expense per city. Means you want to know in every city how much you are providing for salary. Okay, so city 1 is getting how much salary, city 2 is getting how much salary. Let me still show you the output. For city 1, what is the salary? Total salary. That is the salary expense you are doing for city 1, city 2, for city 3. Okay, clear. So you have to group by as per the city. So let me write the query. So I will write select first city because I am doing the group by as per the city. Now I want to know the total. So I have to use the sum function. Now write sum of salary from employee table group by city. Now see the output. I am again making the mistake. Employee table. Sorry. Now see select city. City New York total salary. In Los Angeles total salary. Okay, if you want you can take New York 55,000, 65, 55 plus 65 plus 75. You do the calculation, you can see that this will be this much. Okay, clear? Now let's do this query. Find total salary of all departments. Let me show you the table. Total salary of each department. So you have to tell that what is the total salary for finance department, what is the total salary for HR department, what is the total salary for IT department. That means my output will be, let me create a new page. See, my output will be for HR, what is the total salary, for finance, what is the total salary, and for IT, what is the total salary. So here you have to say the total salary. Clear? So you have to create a group on department. Now let's write the query. See, of all departments, so you have to do as per the department. So select, you have to select department, comma, total salary. So sum of salary from employee group by department. Group by always comes with an aggregate functions. You know the aggregate functions, right? See, in finance department, total salary. In HR department, total salary. In IT department, this is the total salary. So we are spending the most in finance department. Clear? Okay. Now our next question is find departments where the average salary is between 60,000 and 80,000. Finance, HR, IT. Okay, in this department, the average salary is between 60,000 and 80,000. So first you have to create a group of this department, HR department, finance department, IT department. Once you create a group, you take their salary. HR department salary, all this. Finance, IT. Okay. Once you get this salary, now you have to calculate the average of this. So your second step will be HR, finance, IT, and this will be the average salary column. So you will get some average XYZ salary. Clear? Now the thing is that you have to impose a condition, that is salary is between 60,000 or 80,000. So you have to check the condition. If the condition is it between 60,000 to 80,000, yes, so keep it. Is it between 60,000 to 80,000? No, so don't keep it. Next one, yes, so keep finance also. Here you will show their average salary which is meeting the condition. Clear? This is what you have to do. But while putting this condition, you have to use having clause. It's same like where clause, but having clause comes when you use group by clause. Okay. So whenever you are using group by, you have to use this having clause for putting any condition. Let me write the query, then it will be more clear. Okay. So we will write select. We are doing the group by on department. So you have to select department. Now what is the aggregate function? Salary. So you have to write average of salary. Fine. From which table? Employee table. Group by on whom? Group by as per the department. Now the condition. So for this you have to write having, what is the condition? Having average salary, exactly this one, having average salary. So you have to again calculate that average, that average of salary between, between operator 60,000 and 80,000. Clear? The table name is employee. Okay, so now let me show you the output. See, everyone's salary is between 60,000 and 80,000. So that's why 65,000 finance, HR, IT. Okay, if I change condition, let's say if I give 70,000 to 80,000, then what will be the output? Then only HR. Now let's see HR. Okay, so you understand the query. You have to select that column on which you are doing the group by. Always for using group by, you have to use an aggregate operation. Once it is done, now if you want to put any condition, you have to use having clause. Okay, now between operator, these are operator, fine. Now let's do the next question. Find departments where maximum salary is less than 80,000. So what will be the output? Find departments. So you have to group by on departments, HR, finance, IT. That is clear. So you have to find the departments where the maximum salary is less than 80,000. The maximum salary. So you have to create a column called max of salary. Now you have to put a condition, that is having greater than maximum salary is 80,000. Clear? If this satisfies, then give me the output with department. Clear? What you have to do, that should be very clear to you first. Then you can write the query easily. So now I can write select, give me department, always, because I want to do the group by on department. And what is the aggregate function? Maximum of salary. It will give you the maximum of salary as per the department. So you have to write from table name, then you have to write group by department. Group by which column? So group by department. Now you are putting the condition. What is the condition? Having maximum salary is less than 80,000. So max of salary, maximum of salary is less than 80,000. Clear? This is employee table name. Now let me show you. See, finance, maximum salary less than 75,000. HR, maximum salary less than 72,000. Clear? For IT, maximum salary is more than 80,000. That is why it is not shown. Now, find departments where the minimum salary is above 40,000 and total salary is above 1,50,000. Clear? Simple. Same. Select. You have to select the department. What is the aggregate function here? Minimum salary is above 40,000. So you have to calculate the minimum salary. So min of salary from the table name. Group by on which as per the department you want to see. So as per the department. Now you have to give the condition. So having minimum of salary is above, that means greater than 40,000, and total of salary. So you have to calculate sum of salary is above 1,50,000. Okay. Now see, I told you to find the departments where minimum salary is above 40,000 and maximum salary is total salary is greater than 150,000. So here while doing the group by, you have calculated minimum salary. Now you have to also calculate the total salary. So we will write sum of salary. Okay. That is how you will think how to solve this problem. What happened? From having again employee, sorry. Now let me execute this. Still problem. Minimum of salary. I'm really sorry for this kind of error. Dot sum doesn't exist. Sorry, there was a problem with space. There was a space here. That's why it was showing as an error. Okay, now let's see the output. See, finance department, minimum salary, sum of salary. So both the conditions are meeting. That's why this is in the output. Clear? Now the next question. Find departments where the total salary is less than 3 lakh or the average salary is more than 70,000. It's like same. I'll just copy and I'll show you the changes. See, you have to find the departments. So you have to do select departments and you have to do group by department. No problem. Total salary. So you just have to calculate sum of salary. Sum of salary will give you the total salary. Now you are imposing a condition. Total salary is less than 3 lakh. So I can write total sum of salary, having sum of salary less than 3 lakh. So just change the condition, less than 3 lakh. Okay, or that means you have to write or average salary is more than 70,000. So you have to use one more aggregate operation, that is average salary is greater than 70,000. Clear? So you have to calculate this also, these two. Okay, clear? You can see the conditions are made for all the departments. Okay, now group by year of joining and count how many employees joined each year. Group by year of joining. 2018 who have joined, 2017 on 2019 on 2016. So you have to create a group of year of joining and then count how many employees joined each year. So the output will show like this. 2017, 2018, 2019. Let's say 5 people, 4 people, 7 people. Okay, that's what you have to give. This is the count. Okay, so you have to create the group based on the year. Okay, now let me write the query. So we can write select. You have to extract the year from the joining date. For that you have to use the year function. So joining date. So you are extracting the year. Okay, now you have to show the count also. The aggregate operation is count here. So count of, let's count employee ID. Let me just click it here. Employee ID. Yeah, fine. From employee table, you are grouping on which as per the year. So again, year of joining date. Okay, now employee group by joining date, and now you are no condition. Okay, so you are selecting year of joining date, you are calculating the count from the table name, and then you are doing the group by on year of joining date. Okay, now let me show you. See, on 2018 one people, let's see the table first. 2018 John, only John. 2017 only Jen, and repeating 2020. See, Alice has joined and Steve. So two people have joined on 2020. Let's check this one. See. Okay, clear. So you can calculate in this way. Fine. Now the last one. Group by year of joining and calculate the average salary for each year. I think now you can do this. Group by year of joining. So 2017, 2018, 2019. And calculate average of salary. So you have to tell the average salary. Okay. This is how it will look. Simple. First we will select what to select, year of joining date, because we are going to do the group by as per the year. Okay, now you calculate average salary. So average salary, right? Average salary for each year. So you have to just group by, again year you have to calculate from joining date. Okay, and you have to select this from table name employee. Clear? So select, calculate the average from employee table, group by joining date. Okay, fine. So group by is a very simple concept. You just have to do some practice and always try to see that as per the city, like in every department, when you get these types of question, you have to apply group by, and the column on which you are making the group by, you always have to select. Okay, and it always comes with some aggregate functions, and after that if you want to put some condition, then you have to use having, just like where if you are using group by you have to use having. Okay, so bye, happy learning. Today we are going to understand about joining in SQL. Whenever you work in a database, your data will be stored in multiple tables and you may need some information which are scattered in different tables. So your first job will be joining the table. Then only you can write queries to fetch the data from the table, right? So today we are going to learn how we can join different tables, what are the types of joining we can perform, and then we will learn how we can write SQL queries to fetch the data from a joined table. Okay, clear? Now see, we have a database. The name of our database is our company, and inside this database we have two tables, department table, employee table. In department table we have department ID, department name. In employees table we have employee ID, employee name, department ID, manager ID. Now I ask you a question. Give me the name of the employees posted in which department. Simply I want to know Alice posted in which department, Bob posted in which department, and Tony posted in which department. So you can understand that I need two columns. Alice, Bob, Tony, name of the employees, and I want to know they are posted in which department. So the name of the department. So one column is in employee table, one column is in department table, right? So how can you give me this result? For that you have to join these two tables, the employee table and the department table. And to join two tables, you need a common column, right? So what is the common column here? The department ID. See, this is the department ID in department table. This is the department ID in employee table. So based on these two columns, you have to perform the joining. Once you get a single table containing all the columns, department ID, department name, employee ID, employee name, again department ID and manager ID. So once you get this table, now you can fetch these particular columns from the table. Clear? Okay, now you understand the bigger picture. Now to join this, you can do different types of joining. Cross join, inner join, left join, right join, self join, full join. It depends on your query. You can select which kind of joining will give you the better result. Okay, so today we are going to understand each of them in depth. First, let me clean this. Then I will create these two tables, department table and employee table in MySQL workbench. There I will show you every types of join we can perform. Okay, so let me open MySQL workbench. First, our database is created. Let's use the database. Now inside the database, department table, department ID, department name, insert the values. These are all DDL commands, you know these things. Now I'm creating employee table. I am inserting values. These are DML commands. Okay, first one is cross join. Cross join produces a Cartesian product of both the tables. Let me show you first what will be the output. Then we will learn how to write these queries. Okay, simple. You take the first row, multiply with all the rows. You take the second row, multiply with all the rows. Third row, multiply with all the rows. Okay, it's like two for loops. For these all rows, again for all these rows. Okay. Now let me run the SQL query. Then I will show you the result and explain you again. So how can we write the query? Select star from employees. Here the keyword is cross join because you are performing cross join with which table? Department table. So cross join departments. Now if I execute this query, see this is how you can do the cross join. Let me write the output for you here. See the output is like this. First one is ID, name, department ID. This is the first table, manager ID. Clear? Then ID, name. So first 1 Alice 1 null with be multiplied with first one HR. Second again 1 Alice 1 null will be with this one 2 finance because we are inside the first for loop. Again 1 Alice 1 null 3 cells. Okay. Okay, now the inner loop is completed. Now again the first loop, for loop. So we will go to second row, Bob. Now see 2 Bob 2 1. First one is 1 HR. Again 2 Bob 2 1 1. Sorry 2 finance. Clear? Again we will take 2 Bob 2 1 3 cells. Done. Now inner loop is completed. Now again outer loop. This one 4 Tony 7 2. So 4 Tony 7 2. 1 HR 1 HR. Again 4 Tony 7 2. 2 finance 4 Tony 7 2. 3 cells. You understand? So it will be 3 into 3 result. Total 9. 1 2 3 1 2 3 1 2 3. Total 9. Okay, because it is a simple multiplication. With each of these rows, you add all of them. Second row, add all of them. Third row, add all of them. Clear? This is how Cartesian product work. Now let me please erase this. And see the output here. You can see that it is not following that particular order. Instead, it is as see HR altogether, finance altogether, sales altogether. It depends on database engine. It will show you the output. But if you see that total values in the output will be same. Okay, you just take a pen and paper, then try to do this and then check with the result. You will be able to see the same result but may not be in same order because that depends on database engine. Okay. Now let me show you what is inner join. Inner join return only the rows that have matching values in both the tables. Here we can write only the matching values, that is inner join. So if you know what is Venn diagram, then inner join is if this is employee table, if this is department table, this is what is called inner join. Only the matching values. See, what are the matching values here? Department ID. You have to match with the common column. Don't forget that. So department ID 1, 1 HR. Matching? Yes. So this will be in the output. 1 Alice, 1 null, 1 HR. Clear? Second one, 2. Is it matching? Yes. So next output will be 2 Bob, 2 1 2 finance. Clear? Now the 7. Is it matching? No. 3. Is it matching? No. So these two values will not be there. So this will be our output. Let's see. So same select star from employees You are doing inner join. So the keyword is inner join with departments. But you have to match with a common column. The common column is department ID. So let's write the common column on employees table dot in let me refresh it here. Tables in employees table. This is ID. Okay. So table dot column name equals to no, sorry, we have to match with department ID. So employees dot department underscore ID equals to, in department table, see here it is ID. So table dot ID column. Now let me execute this. What happened? Sorry, employees table. Okay, now let me run this. Now see, 1 Alice, 2 Bob. As we expected, this is the output. Clear? Now let's understand the left join. Left join means all the values from left, and matching values from right. So this is our left table, this is our right table. All the values from left. So you have to write 1 Alice, 1 null, 2 Bob, 2 1, 4 Tony, 7 2. Now see what are the matching values. Department ID 1 matching. So we can write 1 HR. Department ID 2 matching, 2 finance. So we can write 2 finance. Now department ID 7, is it matching? No. So we have to write null null. Okay. And here we will not think about this because we are doing left join and this is the right table. Clear? Now let's see the query. So we can write select, I'll select all column from table name is employees and I am performing left join. And while you are performing left join, the table name written in left side is considered as left table. Okay. Left join departments on employees dot department ID, the same as above because the common column is same. You just have to keep in mind which is the common column. That's all. Now we are performing left join. Let's see the output. Alice, Bob, Tony. All from the left side. And here in case of Tony, as it is not matching, these are null. You can see here as we did null 1 HR 2 finance. But in case of Tony, it is not matching, it is null. And 3 cells, it is not given any preference because this is the right side table. Clear? Now what is right join? Right join is exactly opposite. You will take all the values from right table but only the matching values from the left table. All from right but matching only from left. Clear? So what will be the output? All the values from the right table, matching values in the left table. So let's write the query. I'll not type again. I'll just copy. So let me copy and paste it here. Just write right. Again the same role which is written in the left side is a left table, which is written on the right is the right table. So here right table is the department table and I am giving preference to right table. All the values from right table but matching values from the left table. Now see Alice, Bob and 3 cells. In case of 3 cells there is no matching values in the left table. So I am putting null. Okay. 1 HR, 2 finance, 3 cells. So automatically you have to write 1 HR, 2 finance, 3 cells. This is the right table. What are the matching values? Alice, Bob is matching. Tony is not matching. So I will write Alice and all the details of Alice, Bob, all the details of Bob. But there is no matching. So there it will be null, 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 null. Clear? That is what is our output. Hope it is clear. Exactly opposite of left join. Fine. Now we will understand what is self-join. Self-join means when you are joining the same table. Let's say you want to join employee table with employee itself. That means you have two tables. ID, name, department ID, manager ID. This is your employee table, right? And you have one more table, the same one. ID, name, department ID, manager ID. So you are making a join of same table. You may wonder that why do I need to do this kind of joining? That you will understand when we will do a query like finding the manager of employees. For that type of queries, you will understand the importance. For now, just learn how this join works. This works, you take all the values from this table and you match with all the values of this table. Okay, same table duplicated and you are creating a connection. So we can say joining a table with itself only. That is known as self join. So I am joining self. So I can write select star from employees self join again with employees. Now see what is the output. If I write in this way, then what will be the output? See what I am doing, I said you I am joining employees table with employees table itself. So I have two employees table and I am making a join of this. So it will simply take the first one, take all of them, take the second one, take all of them. So you can simply say that this is nothing but Cartesian product, or we can say cross join for now, if we do not put any condition, right? It is just ID name department ID manager ID, again ID name department ID manager ID. So you can understand the same table is joined and there every combination is tried out. Okay. So self join is nothing but a Cartesian product without any condition. Now my question is, why do we need to do this type of peculiar joining? Why? For this I have copied the table employee table. Now I have a question. Tell me the employee's name with their manager's name. How can you fetch this? Employee's name and manager's name. There is no direct column called manager's name, but you can calculate this. See how. Alice, who is the manager of Alice? Null, so no manager. Bob, who is the manager of Bob? 1. 1 is the employee ID of whom? 1 is the employee ID of Alice. So we can write this is Alice. So Bob's manager is Alice. Same way, Tony, who is the manager ID? 2. 2 is the employee ID of whom? Bob. So Tony's manager is Bob. So we can simply write Bob, Alice, Tony, Bob. Alice's manager is not known. But how? How to write this query? Can you tell me how can you write this query? You are getting this from a single table. But how? There is no direct column. Okay, so you are doing a match. How you are doing the match? Let me show you. The same table, ID, name, department ID, manager ID. Once again, ID, name, department ID, manager ID, right? Here you have 1 Alice, 1 null, 2 Bob, 2 1, 4 Tony, 7 2. Same 1 Alice, 1 null, 2 Bob, 2 1, 4 Tony, 7 2. Right? You have same employee table. Now you are checking the manager ID. Null. Null means you have to do nothing. So simply reject it. You are taking the next manager ID. 1. Now you are checking 1 is the employee ID of whom? So you are checking this column with this one. 1 is the employee ID of Alice. So you are taking this value. Now 2 is the manager ID of which employee? This one. Here it is matching. So you are getting Bob. So you are understanding. You are doing the matching with manager ID with ID. So you are taking this column, you are taking this column, you are making a matching simply. So that's why I am taking self join. So see how to write this query. You are taking employees. So first table you have to give a name, that is E1. Then only you can express this, right? This one is E2. So E1's manager ID column will be matched with E2's ID column. Clear? So we will write on E1's manager ID column equals to E2's employee ID column. So it is only ID, I think, not employee ID. Okay. Clear? So same table, but you are taking two different columns. That's why we are doing self joining. Now if I execute this, to sorry, I forgot to give the name. This is E1 and here you have to write E2. Okay, this is how you are renaming the table. So still now, sorry, you don't have to write self, you just write join, then it will work. This is this main self join. See, To ID, name, department ID, manager ID, same way. ID, name, department ID, manager ID. Now see, manager ID and ID is matched. So see, 2 and 2. You can see 2 is matched with 2. So Bob. 1 is matched with 1. Right? 2 is matched with 2. Because manager ID and ID is matched here. So now from here you can fetch whatever column you want to fetch. Now the last one is full join. Full join returns all records from both tables with nulls for non-matching rows. So for these two tables, if we perform full join, then see how it will look. ID, name, department ID, manager ID, for department ID, name. Right? These two tables. Full join, all the values will be there. It will look like this. All the values will be there. And if there is no matching values, then it will be null. So first I will take this one. 1 Alice, 1 null. Now see, 1 HR. So it is matching. So 1 HR. Next one, 2 Bob, 2 1. Now department ID 2 matching. So it will be 2 finance. Now take this one, 4 Tony, 7 2. Department ID 7 not matching. So it will be null null. Now all these 2's are done, but 3 cells is remained. So I will write 3 cells. But there is no matching values in employee table. So these all will be null. Clear? So you are taking all the values from both the table, but if there is no match, those will be filled as null values, null values. This is what is full join table. Clear? Let me revise all the things. Okay, so first we have learned cross join. So take this one, join with all of them. Take this one, join with all of them. Take this one, join with all of them. That is cross join. Then we have learned left join. That means take all the values from the left table and matching from the right table. Then we have learned right join, that is take all the values from right table and the matching values from the left table. Then we have learned full join, that is taking all the values from left table, from right table, and if it is not matching, put the null values. Okay. So and self join means that join one table with itself to find this kind of manager employee types of query. Okay. So these are the types of join we can perform. Now in our next class, we will solve some SQL queries where we will learn how to implement this join to fetch any data by joining tables. Clear? So bye, happy learning. Today we are going to understand about joining in SQL. Whenever you work in a database, your data will be stored in multiple tables and you may need some information which are scattered in different tables. So your first job will be joining the table. Then only you can write queries to fetch the data from the table, right? So today we are going to learn how we can join different tables, what are the types of joining we can perform, and then we will learn how we can write SQL queries to fetch the data from a joined table. Okay, clear? Now see, we have a database. The name of our database is our company. And inside this database, we have two tables, department table, employee table. In department table, we have department ID, department name. In employees table, we have employee ID, employee name, department ID, manager ID. Now I ask you a question. Give me the name of the employees posted in which department. Simply I want to know Alice posted in which department, Bob posted in which department, and Tony posted in which department. So you can understand that I need two columns. Alice, Bob, Tony, name of the employees, and I want to know they are posted in which department. So the name of the department. So one column is in employee table, one column is in department table, right? So how can you give me this result? For that you have to join these two tables, the employee table and the department table. And to join two tables, you need a common column, right? So what is the common column here? The department ID. See. This is the department ID in department table. This is the department ID in employee table. So based on these two columns, you have to perform the joining. Once you get a single table containing all the columns, department ID, department name, employee ID, employee name, again department ID and manager ID. So once you get this table, now you can fetch these particular columns from the table. Clear? Okay, now you understand the bigger picture. Now to join this, you can do different types of joining. Cross join, inner join, left join, right join, self join, full join. It depends on your query. You can select which kind of joining will give you the better result. Okay, so today we are going to understand each of them in depth. First, let me clean this. Then I will create these two tables, department table and employee table in MySQL workbench. There I will show you every types of join we can perform. Okay, so let me open MySQL workbench. First, our database is created. Let's use the database. Now inside the database, department table, department ID, department name, insert the values. These are all DDL commands, you know these things. Now I'm creating employee table. I am inserting values. These are DML commands. Okay, first one is cross join. Cross join produces a Cartesian product of both the tables. Let me show you first what will be the output. Then we will learn how to write these queries. Okay, simple. You take the first row, multiply with all the rows. You take the second row, multiply with all the rows. Third row, multiply with all the rows. Okay, it's like two for loops. For these all rows, again for all these rows. Okay. Now let me run the SQL query. Then I will show you the result and explain you again. So how can we write the query? Select star from employees. Here the keyword is cross join because you are performing cross join with which table? Department table. So cross join departments. Now if I execute this query, see this is how you can do the cross join. Let me write the output for you here. See the output is like this. First one is ID, name, department ID. This is the first table, manager ID. Clear? Then ID, name. So first 1 Alice 1 null with be multiplied with first one 1 HR. Second again 1 Alice 1 null will be with this one 2 finance because we are inside the first for loop. Again 1 Alice 1 null 3 cells. Okay. Okay, now the inner loop is completed. Now again the first loop, for loop. So we will go to second row, Bob. Now see 2 Bob 2 1. First one is 1 HR. Again 2 Bob 2 1 1. Sorry 2 finance. Clear? Again we will take 2 Bob 2 1 3 cells. Done. Now inner loop is completed. Now again outer loop. This one 4 Tony 7 2. So 4 Tony 7 2. 1 HR 1 HR. Again 4 Tony 7 2. 2 finance 4 Tony 7 2. 3 cells. You understand? So it will be 3 into 3 result. Total 9. 1 2 3 1 2 3 1 2 3. Total 9. Okay, because it is a simple multiplication. With each of these rows, you add all of them. Second row, add all of them. Third row, add all of them. Clear? This is how Cartesian product work. Now let me please erase this. And see the output here. You can see that it is not following that particular order. Instead, it is just see HR altogether, finance altogether, sales altogether. It depends on database engine. It will show you the output. But if you see that total values in the output will be same. Okay, you just take a pen and paper, then try to do this and then check with the result. You will be able to see the same result but may not be in same order because that depends on database engine. Okay. Now let me show you what is inner join. Inner join return only the rows that have matching values in both the tables. Here we can write only the matching values, that is inner join. So if you know what is Venn diagram, then inner join is if this is employee table, if this is department table, this is what is called inner join. Only the matching values. See, what are the matching values here? Department ID. You have to match with the common column. Don't forget that. So department ID 1, 1 HR. Matching? Yes. So this will be in the output. 1 Alice, 1 null, 1 HR. Clear? Second one, 2. Is it matching? Yes. So next output will be 2 Bob, 2 1 2 finance. Clear? Now the 7, is it matching? No. 3, is it matching? No. So these two values will not be there. So this will be our output. Let's see. So same, select star from employees. You are doing inner join. So the keyword is inner join with departments. But you have to match with a common column. The common column is department ID. So let's write the common column on employees table dot in let me refresh it here. Tables in employees table. This is ID. Okay. So table dot column name equals to no, sorry, we have to match with department ID. So employees dot department underscore ID equals to, in department table, see here it is ID. So table dot ID column. Now let me execute this. What happened? Sorry, employees table. Okay, now let me run this. Now see, 1 Alice, 2 Bob. As we expected, this is the output. Clear? Now let's understand the left join. Left join means all the values from left and matching values from right. So this is our left table, this is our right table. All the values from left. So you have to write 1 Alice, 1 null, 2 Bob, 2 1, 4 Tony, 7 2. Now see what are the matching values. Department ID 1 matching. So we can write 1 HR. Department ID 2 matching, 2 finance. So we can write 2 finance. Now department ID 7, is it matching? No. So we have to write null null. Okay. And here we will not think about this because we are doing left join and this is the right table. Clear? Now let's see the query. So we can write select, I'll select all column from table name is employees and I am performing left join. And while you are performing left join, the table name written in left side is considered as left table. Okay. Left join departments on employees dot department ID, the same as above because the common column is same. You just have to keep it in mind which is the common column. That's all. Now we are performing left join. Let's see the output. Alice, Bob, Tony. All from the left side. And here in case of Tony, as it is not matching, these are null. You can see here as we did null 1 HR 2 finance. But in case of Tony, it is not matching, it is null. And 3 cells, it is not given any preference because this is the right side table. Clear? Now what is right join? Right join is exactly opposite. You will take all the values from right table but only the matching values from the left table. All from right but matching only from left. Clear? So what will be the output? All the values from the right table, matching values in the left table. So let's write the query. I'll not type again. I'll just copy. So let me copy and paste it here. Just write right. Again the same role which is written in the left side is a left table, which is written on the right is the right table. So here right table is the department table and I am giving preference to right table. All the values from right table but matching values from the left table. Now see Alice, Bob and 3 cells. In case of 3 cells there is no matching values in the left table. So I am putting null. Okay. 1 HR, 2 finance, 3 cells. So automatically you have to write 1 HR, 2 finance, 3 cells. This is the right table. What are the matching values? Alice, Bob is matching. Tony is not matching. So I will write Alice and all the details of Alice, Bob, all the details of Bob. But there is no matching. So there it will be null, 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 null. Clear? That is what is our output. Hope it is clear. Exactly opposite of left join. Fine. Now we will understand what is self join. Self join means when you are joining the same table. Let's say you want to join employee table with employee itself. That means you have two tables, ID, name, department ID, manager ID. This is your employee table, right? And you have one more table, the same one, ID, name, department ID, manager ID. So you are making a join of same table. You may wonder that why do I need to do this kind of joining? That you will understand when we will do a query like finding the manager of employees. For that type of queries you will understand the importance. For now just learn how this join works. This works, you take all the values from this table and you match with all the values of this table. Okay, same table duplicated and you are creating a connection. So we can say joining a table with itself only. That is known as self join. So I am joining self, so I can write select star from employees self join again with employees. Now see what is the output. If I write in this way, then what will be the output? See what I am doing, I said you I am joining employees table with employees table itself. So I have two employees table and I am making a join of this. So it will simply take the first one, take all of them, take the second one, take all of them. So you can simply say that this is nothing but Cartesian product, or we can say cross join for now, if we do not put any condition, right? It is just ID, name, department ID, manager ID. Again, ID, name, department ID, manager ID. So you can understand the same table is joined and there every combination is tried out. Okay. So self join is nothing but a Cartesian product without any condition. Now my question is, why do we need to do this type of peculiar joining? Why? For this, I have copied the table employee table. Now I have a question. Tell me the employee's name with their manager's name. How can you fetch this? Employee's name and manager's name. There is no direct column called manager's name, but you can calculate this. See how. Alice, who is the manager of Alice? Null, so no manager. Bob, who is the manager of Bob? 1. 1 is the employee ID of whom? 1 is the employee ID of Alice. So we can write this is Alice. So Bob's manager is Alice. Same way, Tony, who is the manager ID? 2. 2 is the employee ID of whom? Bob. So Tony's manager is Bob. So we can simply write Bob, Alice, Tony, Bob. Alice's manager is not known. But how? How to write this query? Can you tell me how can you write this query? You are getting this from a single table. But how? There is no direct column. Okay, so you are doing a match. How you are doing the match? Let me show you. The same table, ID, name, department ID, manager ID. Once again, ID, name, department ID, manager ID, right? Here you have 1 Alice, 1 null, 2 Bob, 2 1, 4 Tony, 7 2. Same 1 Alice, 1 null, 2 Bob, 2 1, 4 Tony, 7 2. Right? You have same employee table. Now you are checking the manager ID. Null. Null means you have to do nothing. So simply reject it. You are taking the next manager ID. 1. Now you are checking 1 is the employee ID of whom? So you are checking this column with this one. 1 is the employee ID of Alice. So you are taking this value. Now 2 is the manager ID of which employee? This one. Here it is matching. So you are getting Bob. So you are understanding. You are doing the matching with manager ID with ID. So you are taking this column, you are taking this column, you are making a matching simply. So that's why I am taking self join. So see how to write this query. You are taking employees. So first table you have to give a name, that is E1. Then only you can express this, right? This one is E2. So E1's manager ID column will be matched with E2's ID column. Clear? So we will write on E1's manager ID column equals to E2's employee ID column. So it is only ID, I think, not employee ID. Okay. Clear? So same table, but you are taking two different columns. That's why we are doing self joining. Now if I execute this, 2 sorry, I forgot to give the name. This is E1 and here you have to write E2. Okay, this is how you are renaming the table. So still now, sorry, you don't have to write self, you just write join, then it will work. This main self join. See, to ID name department ID manager ID, same way, ID name department ID manager ID. Now see, manager ID and ID is matched, so see 2 and 2, you can see 2 is matched with 2, so Bob. 1 is matched with 1, right? 2 is matched with 2 because manager ID and ID is matched here. So now from here you can fetch whatever column you want to fetch. Now the last one is full join. Full join returns all records from both tables with nulls for non-matching rows. So for these two tables, if we perform full join, then see how it will look. ID, name, department ID, manager ID for department ID, name, right? These two tables. Full join, all the values will be there. It will look like this. All the values will be there. And if there is no matching values, then it will be null. So first I will take this one. 1 Alice, 1 null. Now see, 1 HR. So it is matching. So 1 HR. Next one, 2 Bob, 2 1. Now department ID 2 matching. So it will be 2 finance. Now take this one, 4 Tony, 7 2. Department ID 7 not matching. So it will be null, null. Now all these 2's are done, but 3 cells is remained. So I will write 3 cells. But there is no matching values in employee table. So these all will be null. Clear? So you are taking all the values from both the table, but if there is no match, those will be filled as null values, null values. This is what is full join table. Clear? Let me revise all the things. Okay, so first we have learned cross join. So take this one, join with all of them. Take this one, join with all of them. Take this one, join with all of them. That is cross join. Then we have learned left join. That means take all the values from the left table and matching from the right table. Then we have learned right join, that is take all the values from right table and the matching values from the left table. Then we have learned full join, that is taking all the values from left table, from right table, and if it is not matching, put the null values. Okay. So and self join means that join one table with itself to find this kind of manager employee types of query. Okay. So these are the types of join we can perform. Now in our next class, we will solve some SQL queries where we will learn how to implement this join to fetch any data by joining tables. Clear? So bye, happy learning. Today we are going to understand subquery in SQL. Okay, subquery means one query inside another query. This is a simple topic, but how and why, that we will understand by doing queries. Okay, so I have already created some tables. Let me show you. The resigned employees table. Here you have the employee ID of the employee who has resigned. Next table is employee table. Here we have details about the employees. Employee ID, employee name, department ID, their salary, their performance rating. Okay, we have one more table about departments. There you have department ID and department name. And another table is bonus table. I have not inserted any values inside the table. I will using subquery. Okay, so this is the picture, and now we are going to solve the queries using subquery. Okay, now see, subquery can be used in different clause. In select clause, where clause, insert clause, update, delete. Okay, let's do one by one. First one is subquery in select clause. Here you have to fetch department name with employee name. The same query we did using joining also, but here we will do using subquery. So what is our output? Employee name with department name. So in our output we have to write Alice, Bob, Charlie, David, Emma. In which department? Sales, IT, sales, HR and IT. That will be your output. Okay. So how can we solve the query? You have to join these two tables using subquery, not by join. Okay, you understand what is your task. Now see, we have to match the common column. This is the column. This one is the common column. Department ID of employee table, department ID of department table. So we will match these two columns and we will fetch this column and corresponding this column. Okay, so let's write the subquery. So we can write select, we have to select name, right? So we will write name from which table? Employees table. So it will give you the name from the employees table. No problem with that. But I want this also, department name. So how can I fetch that? So here you have to show the department name. For that we will write a subquery, one more query inside this query. That is why it is called subquery. So now I want to select department name. Just let me see. Department name. Okay, sorry. Department name from which table? Department name is in department table. So you have to write select department name from department table. So this will give you the department name from department table. But I am not going to fetch all the departments. I have to check the condition also where department ID is matched. So I can write where departments dot department underscore ID equal to employee dot department underscore ID. Just a second, there it is department ID. So you just have to remember the column name. In employees I think it is department ID. Yeah, this is fine. Okay, so see what we have done. We have selected name from the employees table and we have selected one more thing from department table, that is department name, but with a condition. What is the condition? Where department ID is matched. Okay, now let me show you the output. Employees from employee table from departments. I'm really sorry. So now see, Alice sells, Bob IT, Charlie sells, David HR, Emma IT. Okay, so you understand how you are fetching this. Here if you want, you can rename this as department name because it is not showing good. Okay. Okay. But this is not a good query at all. It is always better if you do this using joining. Whenever you can solve any query using joining, it is better that you avoid subquery. Okay, but we have to learn. Now the next one is subquery in where clause. So the query is find employees with salaries higher than average. Now see, find employees. Let me clean this. Find employees with salary greater than average. So first you have to make an average. Once you get the average, then you have to check whether L is greater than average. If yes, keep in the result. Whether Bob greater than average. If yes, keep in the result. Charlie greater than average. If no, then don't keep in the result. Okay, so you understand. First you have to calculate the average. Then you have to check with every employee name. Clear? So now let's write the query. First I have to calculate the average salary. So select average salary. You know how to calculate average salary by average function from employee table. So it will give me the average salary. Okay, this is the average salary. So you have to check who has more salary than 72,000, right? So I have to write select name, comma, salary from employee table where salary greater than this salary. What it will do? It will take Alice, it will take 60,000, right? Now, once it get Alice and 60,000, now it will check 60,000 is greater than 72,000. If yes, then show Alice. So same way it will traverse every row and see these are greater than 72,000. So Bob, Charlie, Emma getting higher salaries than average salary. Okay. Next one is subquery in insert. Insert, you know, that is used for inserting any values inside a table. I have told you that I have created a bonus table and there is no value. So now I will insert some values inside the bonus table. Okay, now you want to give bonus to them who are performing well. Okay, now see, in employee table we have a column called performance rating. So I want to give bonus to them where the performance rating is excellent. Simple, insert into table name and the values. What are the values in bonus? Sorry, what are the column name? Employee ID, name, bonus amount. So you have to write employee ID, amount, right? Click here, I will get from here employee ID, name, bonus amount. Now you will insert the values. So I will take the values from employees table. So select employee ID. In employee ID, I will put the employee ID from the employee table. Name will also be same. And bonus amount I will calculate. Let's say I want to give 10% of their salary. So I can write 0.1. Okay. From table name. So you understand, I am taking the employees and putting their employee ID into this employee ID column, into name column, and bonus amount as salary into 0.01. Okay, now I will put a condition. The condition is not for everyone but for good performance. So performance underscore rating equal to excellent. Okay, now if I run this query, there is a problem, that is not employees, it is employee. So now see, this is done. So let's see the table. See, okay. So they are getting they are high performer, so that's why they are getting this amount of bonus. Bonus, you know how bonus is calculated by salary into 0.1. Clear? So here also you are using the subquery but in insert clause. Okay, so the next one is subquery in update statement. You have to increase the salary of sales department employees by 10%. Okay, so see how to do this. First you have to find who are working in sales. So sales department's department ID is 1. So once you get this 1, now you can update their salary. Okay, so your first step, your own inner query will be to find the department ID. Then you will update the salary where department ID is matched. Right, now let's write the query. So first the inner query will be select department ID from departments table where department name equals to sales. Okay, now let me show you, it will show you 1, right? Fine. Now I want to update their salary. So I can write update. Update statement is written in this way. Update table name set salary equals to salary into 1.10 where the condition is where department ID, you want to say that in this table increase their salary where department ID is in this one, right? So I can write where department ID in this one. Okay, see, now it is done. I gave the wrong name. Okay, first finding the department ID and then we are updating the salary. Okay, now next one is subquery in delete statement. Remove resigned employees. So I created a table called resigned employees 104. I want to remove from employee table. Okay, so let's write the subquery. Delete statement, you know how to delete. Delete from table name condition. Right, now what will be the inner query? I want to delete who have resigned. So I want to delete the data which are residing in resigned employees. Okay, so I have to first fetch that. So I can write select employee ID from resigned employees table. Okay, so it will give you, let me show you, it will give you 104. This is in resign table. Now I want to delete this employee ID from employee table. So I'll write delete from employee where employee ID, the condition is employee ID in this one, or we can write equals to, but here employee ID may be more, so that's why it is better to use in. Now see, it is deleted. Now if I check employees, you can see 104 is deleted. Okay, clear? Okay, now let's understand types of subqueries. Depending on the result of your inner query, subqueries can be divided into 4 groups. One is single row subquery, that means the inner query returns a single value. Multi-row subquery, that means inner query returns multiple values. Correlated subquery means the inner query executes for each row in the outer query, and nested subquery is one subquery inside another query. Okay, so I have created 3 tables. This is the employee table, employee ID, employee name, employee's experience, and department ID. This is the department table, this is the department ID, department name, and this is the budget table. In budget table, this is department ID and it is the budget of that department. Okay, now let's solve some queries, then things will be more clear. First one is single row query. I said that single row query means the inner query gives you a single row output. Okay, let's say I want to know which employee has the maximum experience. Employee have the maximum experience. Okay, so if I see the table, your result will be this is the experience column, so the result will be David. Okay, now let's see how to write this query. First I have to know what is the maximum experience. So max of experience from employees table. Now if I execute this, you can see the maximum experience is 8. Okay, no problem. I have to fetch the name now. So select name from table name where the condition is the experience equals to this one. So that means where you get this experience, that is the 8 years, then you give me the name from that employees column. Okay, so what you are doing, you are taking Alice, you are checking is it 8, because your inner query is giving you 8, right? This one is giving you 8. So every time you are checking the condition, no, then it will be rejected, no, rejected, no, rejected, yes, so it will be fetched. Okay, so you understand that this is single row query because the inner query is giving you the single value. Now what is multi-row query? Let's say I want to know name of the employees who are working in departments where the budget is greater than I want to know the employees who are working in the department where the budget is greater than 12 lakh. Okay, now let's write the query. So first you have to find where the budget is greater than 12 lakh, right? 2 and 3 will be output. So I can write select department ID from budget table where condition is budgets greater than 12 lakh. If I run this, just a second, is it department ID? No, this is department ID. Department ID. Okay, now budgets, select department ID. Budget. I'm really sorry. Now see the department ID 1, 2, 3, 4. All of them. How? Did I give a less 0? Maybe. Yes. Okay. Now it is okay. 2 and 3. So you can see now this is your inner query. So now your inner query is giving you more than 1 rows. So that is why it is known as multi-query, multi-row query. Okay. But what we want, our output is name of the employees. So we have found the department ID. Now we have to find that who are working in this department. So now it's simple. We can write select name from employee table where department ID in this one. That means if the department ID in 2 or 3, then just a minute, then give us the output. Okay, now if I run it, There is a column error, I think. Employees column. Okay, this is department ID. Sorry, this is in table name is employees, department is department. Okay, now see, David, Frank, Alice, Bob, they are working in 2 and 3. David in 2, Bob, Alice 3, Frank in 2. Okay, clear. You can write department ID also, then also you can say. Again, I'm really sorry. Okay, clear. So that is why this is known as multi-row query. Simple thing. Next one is nested query. Nested query means one subquery is inside another subquery. Okay, let me give you a query first. Let's say I want to know the details of employees who are working in the department which has the maximum budget. Okay, so now let's write the query. First you have to find the maximum budget. So we can write select max budget, max of budget from budgets. Right, first you have to calculate. You can see this is the maximum budget. Now we have to find, let me show you. Now we have to find this department ID. Once you get this department ID, then you can connect this department ID with the employee column, with the employee table, right? So you have to write select department ID from budget where budget equals to this one. Okay. Now we will get from budgets table. Now we are going to get that department ID 3 is getting the maximum budget. Okay, so now we have got the department ID. Now we can write select star from employees where department ID in this one. Let me create this. Okay. See, now I have written two queries. First I get the maximum budget, then I am taking which department is getting the maximum budget, then I am taking that please show me the employees who are working in this department ID. Now let me first show you the output. See, Alice and Bob, they are working in department ID. Okay, if I show you, first I am finding this is the highest budget from one query. Then I am finding this is the department ID from the next subquery. Then I am coming here in this table and fetching their details. Okay, so this type of query is called nested subquery. Simple. Now the last one is correlated subquery. For correlated subquery, let me give you an example first. Name of the employees whose experience is greater than the average experience of employees of their department. Okay, so I want to know those employees' name whose experience is greater than the average experience of their department. Okay, so I have to find whether Alice's experience is greater than the employees of his department. Okay, so those who are working in engineering, their average experience is Alice's experience is greater than that or not? That is the query. You first take Alice. Your outer query is taking Alice. Now you are checking what is his department ID. So his department ID is 3. Now you are checking who are the other employees working in the same department. So you can see Bob is also working in the same department. So now what is Alice's experience? That is 6. What is Bob's experience? That is 7. So 6 plus 7 divided 2 is the average, right? So now you get 6.5. Now you will check whether Alice's experience, that is 6, greater than 6.5. No, so Alice will not be in the output. Okay, now you take Bob. So Bob's experience is 7. Again you are checking that Bob is in engineering department. So who are others are working in engineering department? Alice. So now again you are taking Alice's experience. So Bob's experience is 7, Alice is 6 divided by 2, 6.5. You are checking whether Bob is greater than 6.5. No, yes, then Bob will be there in the output. Clear? Now you are taking Charlie. So Charlie's experience is 3. Okay. Charlie's department is 1. Who else is working in Charlie's department? No one. So this is 3. Is it greater than average 3? 3's average will be 3 only. So no. So remove Charlie. Next one is David. David is working in which department? 2. What is the experience of David? That is 8. Who others are working in 2 department? Frank. What is the experience of Frank? 5. So you calculate the average. 13 divided by 2, 6.5. What is the experience of David? David 8. So greater than 6.5? Yes. So David will also be there. Right? Now you take Eve. So I take Eve. What is the Eve's experience? That is 4. Eve is working in which department? 4. Who else is working in Eve's department? No one. So now you check that not greater than. So you can simply remove. Next one is Frank. So I take Frank. Frank's experience is 5. Okay. Frank is working in 2. Who else is working in 2? David. So David's experience is 8. So 8 plus 5 divided by 2, that is 6.5. Now Frank is greater than 6.5. 5 greater than 6.5? No. So Frank is also removed. So you can understand that for every employee, I am doing an inner calculation. That is, I am calculating the average of that employees of the respective department. Okay. So you understand, for every outer query, you are doing a calculation in inner query. Clear? In other cases, what we did? Let's say I wanted to know the maximum experience. So there what I did? I first calculated max experience from employee. So it will give you something 8. Once it has given, once the 8 is executed, then I am fetching the name where the experience is equal to 8. So here you can see, first your inner query is executed, then only your outer query is getting executed, right? But this is the complete different scenario. Here for every outer query, you have to make a calculation in the inner query. Okay. So every inner query is executing whenever any outer query is getting executed. That is why it is called correlated subquery. Both the queries are related to each other. Okay. So I hope it is clear, but a correlated subquery is rarely used. In fact, you can also think that every time it is doing some calculation. So there is a problem with speed. So that's why correlated subquery is hardly used. And in fact, if you can join these 2 tables and can solve your queries, then it is better that you avoid subqueries. Okay, but you have to learn, you have to know the things. So I have explained. Okay, now let's write the query. Select e dot name, e dot experience, and e dot department ID from employees e where e dot experience greater than. Now write the subquery. So I can write select average of experience. I have to calculate the average experience for whom? For the employees who are in the same department, right? So the condition is give it E2 where employee E dot department ID equals to E2 dot department ID. Okay. So we are naming it differently. We are telling it E1 and E2. Okay. The same table, but we are giving different name. So that whenever you get that Alice's department ID is 3, you check that who else is in the same department. Okay. Because you are not taking the average experience of every employee, but only those employees who are present in Alice's department. So you have to find where the department ID is matched. Okay. So that's why we have matched this. Now let's execute this and see what is the result. Department ID and ID from employees E where E dot experience greater than this. See Bob and David. Okay, as we expected. Clear? I hope you have liked this. If you have liked this, please subscribe to my channel. Bye. Happy learning. Today we are going to solve some queries which are frequently asked in an interview, and today we will understand about limit clause and offset clause. Okay, so let me first show you the table I have created for you, that is the employees table. In employees table we have the details of the employees: employee ID, employee name, employee salary, in which department they are posting, and their hiring date. Okay, now let's solve the queries. The first one is retrieve the highest salary. That you know how to do this. You have to use max function. Max function will give you the maximum salary. So if you write in this way, select max salary from employees table. Now let me show you. See, this is giving you the maximum salary. Now I want the name of the employee who is getting the maximum salary. So I can write select employee name from employees where salary equals to this one, right? So you will get the employee name where the salary is the maximum salary. So it will give you the employee who is getting the maximum salary, that is Jack, right? So here you can write employee name comma salary. So now if I run this, you will get Jack and their salary, highest paying employee. Clear? But here you have done this using subquery. So I will do it with limit clause. Now see how can I do it. Select salary from employees order by DSC. If I write this, tell me what will be the output. I am sorry, order by salary column. What will be the output? Here I am just creating an order in descending manner of the salary, right? So if I write select name, then you can employee name, then you can understand that which employee is getting how much of salary, and Jack is getting the highest, Ivy second highest, Charlie third highest, in this order. Okay, but my output will be only Jack and his salary. For that, what you have to do? You have to write limit 1. Limit 1 means give me only one row as output. Limit 1 means I want only one value in the output. If I want to know both of them, first salary, second salary, then I want 2 rows as output, so I'll write limit 2. Clear? If I want the top 5, then I will write 5. So show me first 5 highest paid employees. Okay, you understand? Limit 5 means how many rows I want to see in the output. Okay, now if I do the second one, I want the second highest salary. Here if I write 2, then you will get first and second. But my question is not that. Only IV and this salary. Okay, second highest salary. So same if I copy the code right here, I have to write offset clause. Offset 1. Offset 1 means skip the number of rows. That means skip the first row. And limit means only one row as output. Now let me first show you the output. See, second highest salary. Okay, now tell me then third highest salary. Simple, you can say it right now. First thing, you want how many rows as output? Only one, third highest salary. So limit will be 1, no problem with that. But you want to start from where? Third highest salary. So you want to skip first 2 rows. So I will write offset 2. Offset means skip 2 rows. Okay, give me 1 row after skipping 2 rows. Okay, now let me show you. Okay, this is Charlie. Charlie is the third highest salary getting. Clear? Now if I tell you, give me top 5 earning employees. So just let me copy this and top 5. Okay, first top 5. So I don't want to skip anything. I just want from the top. But I want 5 rows. So how many rows you want to limit? 5. Now let me show you. Jack, Ivy, Charlie, Hank, Grace. So you understand how to solve these types of problem. Now the next one. Retrieve employees rank to 6th to 10th. Let me copy this. 6th to 10th. So how many rows you have to skip? First 5 rows. So offset will be 5. Now how many rows you want to return from 6th to 10th? 6, 7, 8, 9, 10. So 5 rows. Now let me show you. So 5 rows will be returned from 6th to 10th. You can check from the employees table. Clear? So this is the way you will do. Once again I repeat, limit means how many rows you want to return as output, and offset means how many rows you want to skip before fetching your first row. Clear? Now let's do the next one. Fetch last salary. Okay, I want to see who is getting the minimum salary. So select. Can you do this using subquery? Yes, you can. But here we are going to learn about limit only. So we can write select employee name, salary from employees, order by salary ASA. If you don't write, then also it is ascending, but I am writing here. And now I want how many rows? Last one, so only one, so I will write limit 1. See, David is getting the minimum salary. Okay. So you get how we did it. First we have created an order of salary in ascending manner. Then I have fetched the first one. Okay, now do the second one. Fetch second last salary. So if I just copy it, I think now you can tell. We are going to order by in ascending manner. Okay. But second last salary. So I want only one row. So limit 1 is fine. But second last. So I have to skip the first row. So I will write offset 1. Now if I run this, see first one is done. Okay. Okay, now let me show you a second technique without using the offset clause. Okay. Let's say I want to retrieve second highest salary but without offset. So here what you have to do, just same thing but the technique is a bit different. Here also I am ordering on salary column and doing in descending order. Okay. See, Jack, Ivy, Charlie, Hank. But I want second highest salary. So here you have to write limit in this way. 1, comma 1. That means start from the second one and give only one row as output. See, if I want third highest salary, then you have to write limit 2, comma 1. Then it will show Charlie. Okay, so you can understand this is the starting rows and this is how many rows you want to see. Let's say I want to see third, fourth and fifth highest salary. If you can say this, then this is completely clear to you. Same way, I'll just copy, paste here. See, starting from third row. So you have to give limit 2. But up to third, fourth, fifth, not 1. So I will write 1, 2, 3. So here you have to write 3. Then it will start from Charlie, Hank, Grace. Clear? If I write 6th, then just you have to change here and make it 4. Then it will give you 4 output. Okay, so how many? That is decided by this one. And from where? That is decided from the first one. Okay, so you can understand that offset is in the first position right now and limit is in the second position right now. This is also a technique. Okay, so whatever you feel comfortable, you can write in this way. Clear? So if I ask you, write second and third salary from last, lowest. Okay. Then also same, you just have to copy, paste it, but here you can understand this will be in ascending order. So if I execute this, now you can see that this is in ascending order. Now I want second and third, so it is starting from Bob and it is up to Eve. So Bob and Eve will be our output. So then you have to start from 1 and you want 2 rows as output. Okay, this is the starting one. This will start from Bob and this will give you 2 and 3. Bob and Eve. Clear? Now let's do the next one. Now the next question. Fetch the third youngest employee based on hiring date. Let me show you the table. Depending on the hiring date, you have to tell the third youngest employee. Okay. Now tell me, how can you do this? Select employee name, hire date from table, order by. You have to do the order by hire date in DAC manner. Let me show you first what is the output. What happened? Sorry. See, 22nd September 2021. Before that, 15th March 2020. Then 2019, 2018. So you can see this is the descending order of hiring date. So David is the newest employee, youngest employee. Bob is the second youngest employee. But I want the third youngest employee, right? So I have to find Eve and his hiring date. Same way, how can you do this? See, first you have to skip first 2 rows, David and Bob, and you want only 1 row as output. So your limit will be 1. Give me 1 row and skip first 2 rows. So write offset 2. Okay. Now if I run this, clear. So you can get the third youngest employee. If I tell you to find the third oldest employee, then how can you do this? Same, instead of DAC, you have to write ASC. So you will organize them in ascending manner. Once you organize them in ascending manner, then you can apply limit and offset. Okay. Now the next one. Last 3 employees who joined the company. So that means, let me copy this. Last 3 employees. If I delete this, who have joined last? Eve, Bob and David, 2019, 2020, 21. Okay, because these are in descending order. So here you just want David, Bob, Eve. So you are not skipping anything, but you are putting a limit of 3. You want only 3. So I can just write limit 3. Okay. Clear? Now first 5 employees alphabetically. Okay. First let's see them. Employee name from employees. But you have to, this is already in alphabetically, but if it is not, then how can you write? Then you just have to write order by name. If you write order by name and putting nothing, then it will be, employee name. So it will give you the employee name alphabetically. If you want, you can write DSA. Then it will be exactly opposite. Jack, Ivy, Hank, Grace. Okay. But I want 5 employees, right? So I can write limit 5. Okay. Clear? Just delete this. Then it will come alphabetically. Okay. Now if I want from 5th to 10th alphabetically, but from 5th to 10th, then same thing, just limit 5 is okay. No, not okay. 5, 6, 7, 8, 9, 10. So you want 6 values. So limit 6. But you have to skip the first 4 rows. So offset 4. Now if I run this, I can see it is starting from E. So A, B, C, D are already gone. Clear? That is done. And one more. Get the employee whose salary is closest to the average salary. See, select average salary from employees table. First, let's see what is the average salary. Okay, this is the average salary. Now you have to find who is closest to the average salary. Select, I'll take the absolute value. So I'll take salary minus select average salary from employees. So this will calculate the difference of every salary with this average salary, and then I am just ignoring the sign. I am taking the absolute value. Okay, from employees table. Now let's see what is the output. Okay, see, I am getting every one salary minus the average salary. So this first salary is the one which is the closest to the average salary. So we have to just fetch the name. So we can write name. Sorry, this is not in order. So first you have to do the order. So I will write order by order by which column? Order by this column. So let's give a name to this column. So I can write as difference. Okay, difference is the name of this column, right? Let me just show you. If I run this, see, this is the difference column. Now I will order by on this column. So I'll write order by difference. So now it will create the order but in descending manner, sorry, in ascending manner. So I have to write descending. So now it will give you this way. Okay, now you can say this is ordered. Okay, now we have to find the first one with name. So I can write name, employee name, comma, employee name and the first one. So I will put a limit. So I can write limit 1. Let's say. The big difference, I think we have to find the closest. So we have to write ascending. So if I write ascending, then see, now he is the closest one. Hank is the closest one, right? So what we did, we have selected the employee name. We have calculated everyone's salary minus the average salary. We have taken the modulus value, that is ignored the sign. Then we have named it as difference. Then we have ordered on this particular column, that is different. Then we have put a limit. Okay. Now if I want to know who are the 3 employees whose salary is closest to average salary. So instead of 1 employee, I want the name of the 3 employees who are closest. Okay. So same you have to write what? You have to write limit 3. That means return me 3 rows. Okay. You can see they are closest to the average salary. So this way, by using limit, by using offset, you can put a restriction on your result. Okay. So bye. Happy learning. Today we are going to understand about view in SQL. View means virtual table. That means it doesn't exist physically. It exists but virtually. How? Let's understand. This is an employee table. Okay. You have employee ID, employee name, employee's department, employee salary, employee's department ID. Okay. So you have the details of your employees in your company. Now let's say one person joins your company. Okay. Now you want to give him a task. You are telling him that please transfer the employees to some other department. Transfer Alice to finance department. Transfer David to IT department. Okay. So you want to give him this job. But you don't want him to see the salary column. You don't want him to see how much salary Alice gets. So what you have to do? You have to create a separate table containing ID, name, department ID, all these things. Then you can tell your junior to transfer them to another departments, right? Now let's say he has updated the department ID in this particular table. Now what happened? This table is updated. But is it updated? No, because you are not letting him to work with this table. He is working with this table. So this table is not updated. Now what is happening? You are using memory. For this second table, you have to use extra memory. Secondly, your original table is not updated. So you understand what is the problem? To solve this problem, this concept came, that is view. View means you are taking this needed columns and you are creating a view and you are giving it to your junior. So if you are using any particular column or some particular rows or some conditional rows, then you can use this concept called view, right? If you are standing in front of your window, then you can see part of the nature, right? Not the complete one. Same concept is used here. You are not using the complete table, but some parts of the table. That's why it is known as virtual table, or we can call it a logical table, as it is not actually a table and it is not stored anywhere, but it is a part of the original table. Clear? Okay, so you understand what is view? View is a virtual table. It doesn't exist physically, and with the important columns, you can create a view of the original table. Okay, now let's run some queries in MySQL Workbench. I have already created two tables. Let me show you the tables. One is employee tables. We have ID, name of the employees, their salary, their department ID. In department table, we have department ID, department name. Now let's understand how you can create a view. Okay, first create a view from a single table. Okay, from employee table, if I want to create a view, then how can I do it? Let's say I want to work with only those employees who have salary greater than 60,000. Okay, I'll transfer them only to other department. So I have to first fetch who have salaries more than 60,000. Then only I can work with them. So here I need a view. Okay, so first write the DQL query. Select I want ID, name and their department ID. So I can write ID, name, their department ID from table name where condition is salary greater than, let's say, equals to 60,000. Okay, so I have got the details of Bob, Carol, Frank. They are getting more than 60,000. So I will change their departments. Now I have to keep this result in a view. So I'll write on top of this, I have to write create. This is a DDL command because you are defining something. So create view, give a view name. Let's say employee for transfer. Whatever you want, you can give a name and as. Okay. Now if I execute this, your view will be created. Here if you click, let me refresh. Now if I click, see our view is created. The same result. Okay, but now it is stored as a view. So now you can use this view for doing further any query. Okay, clear? Now my question is creating a view from multiple tables. How can you do this? So we have two tables, employee table, department table, and I want to create a view from these two tables. So first you have to join these two tables, and you know how to do the join. Let me show you. Select, let's say e.id, e.name, e.department id from employees. Now if I write join, join means inner join performed here, and I also want not e.department id. Let's say I want the department name from department tables. Okay, that is fine. From employees. Now join with department table. Employees table you have to name as E. Department table you have to name as D. Okay, and on which is the common column here? Department ID. D dot department ID equals to E dot department ID. Right? Just check the column name. Okay, this is a simple join. We have understood this before. Departments. See ID, name, department name. So Alice is in finance department, Bob is in HR, Carol in HR, David in ID, Eve in finance, Frank in human resources. Now I want to do some query on this. Let's say I want to see who are in HR, who are in IT. Okay, so whatever you want to perform, you can perform from this result. So I have to store this result in a view. So simple, again, you just have to write create view DDL command. So you have to give a name, joint view as. Now if I run this, say your view is created. So if I refresh this, another view is created, the same result. Okay, now you can make some queries from this. I want to see only those who are in finance department. So I want details about Alice and Eve. So you can simply write dql command, select name from joined view. This is just exactly treated as a table, but it is a view. It is not existing physically. Remember this. Okay, select name from view where department name. So department name equals to D. Okay. So now if I see, only David is working in IT. Yeah. Okay. So you understand? You can simply create a view and then you can work with your view. Okay, you understand the need of the view. Now if I want to create a view from another view, same, just let's say I want to create a view of those employees who are working in IT. Okay, or let's say who are working in HR. So Bob, Carol, Frank. So here I will write human resources. Okay, I have written some spelling mistake. Human resources, there is a space. See, Bob, Carol, Frank. Okay, now if you want, you can simply store them in another view. So I will write create view, nested view as. Here you are creating a view from a view. First you have created joint view. Now you are creating a view from the joint view. So that is why it is called as nested view. So now if you execute this, another view will be created. Let me show you. You can see this is a nested view. Understand? Okay. Now let's say I want to update a view. See, this is the employee for transfer view, and here I want to transfer Bob to 103 department. Okay, I will work with the view. I will update this view and you can see that the main table will be automatically updated. See, I will write update employee for transfer. Sorry for the spelling. Set department. What is the, just let me say, department ID equals to 103. For whom? Sorry, for Bob only. So where name equals to Bob. Now let me show you. Sorry, the spelling mistake. So it's employee. Give some meaningful name, that is better. See, now it is done. So you can see, let me show you the view first. Let me refresh this. Now see, Bob is transferred to 103 department, right? Now if I check the employees table, Bob in 103. Earlier it was in 102. Clear? So you can see I have not worked with the table. I have worked with the view which is created from the table, and I have updated the view only. I have not touched the table, but you can see the table is also updated. Okay, so you understand what is the benefits of view. You are just giving only the columns you want him to see. He is working on that column, but your original table is getting updated without letting him see the confidential columns. Clear? So this way you can update, but sometimes you may want to put some restriction so that your junior cannot update whatever he wishes to update, right? So that we can do with check option. So let me first create a view for this. Create view with finance employees. So finance employee as select star from employees table where department id equals to 101. We have to apply the check option. So I will write with check option. Now if I execute this, now if I want to update this, just like before, same, I want to update, you have to give the view name. Our view name is finance employee. I want to transfer the finance employees to set, just let me show you the view once. Finance employee, see this is the view, okay, 101 their department id. I want to set their department id to 102. Okay, I want to send the finance employees to HR department. So set department id equals to 102. Okay, to everyone, let's say. You can give some where condition or you can just send everyone. Now see, with check option failed company finance employee. So you have put a check option, so you just cannot update like this. Okay, so you get my point. This is the way you can put some restrictions also on updating. Next concept, creating a table from a view. That is very simple. Create table. Take this one. I want to create a table of those employees who are working in IT. So I can write create table IT employees. Create table name as now. So select star from joint view where the department name is IT. So where department name equal to IT. So you understand what is our task from joint view. This is a view we have created. From this view we are creating a table. Table of which employees who are working in IT. So simply I have first extracted that who are working in IT from the joint view, and now I have created a table of them. Okay, this is very simple, no issues. So you can see table will be created. Now if you refresh, you see here in this table section IT employees is created. We have Bob, Carol, David because they are working in IT. Okay, so you can create a view from a table, you can create a table from a view. Now you can use order by in a view. Let's say I want to create a view where their salary is sorted. Let me show you the employees table once. I want to create a view where the salary is sorted. Here the salary is not sorted. Okay. Now how can I do this? Same way, create view. Let's say sorted employees as select star from employees, and you have to do the sorting. So you can write order by which column? Salary in descending order. If you don't write descending, it will be in ascending order. Now see, view will be created. Let me first show you sorted employees. See, now 80,000, 70,000, 60,000, 55, 52, 50,000. Okay, this is a view. This is not a table. Okay, but the salary is in sorted order. Okay, so in view don't write order by, but while making the selection from the original table you can write the order by. Clear? Okay, now the next one is updating data through a view only for updatable views. We have understood how to do updation, but one thing just keep in remember that you cannot update every view. So what are the scenarios when you cannot update? When you join from multiple tables. From a single table you can update, from multiple tables you can't. When you use any aggregate operations like count, sum, like these things, then you cannot update. Okay, when you use distinct clause or when you use group by. Okay, so when you are creating a view using these things, you cannot simply update them. Next, your view must contain all the primary columns of the original table. If not there, you cannot update, right? Or if you are using any calculated field, let's say you have calculated salary with you have multiplied 10 with the salaries, you have increased their salary and you have created a view. Now if you want to update the view, no, it is not possible. So for calculated fields also you cannot use. Okay, so you have to keep these things in mind, that you cannot update view all the times, but for these kinds of scenario you simply cannot. When you are using join clause, that means when you are joining from multiple tables. Okay, clear? Now you can query from the views. I have already shown you, but if you just want, can check. Select star from sorted employees. Sorry, select star from sorted employees. I want to see all the details from the sorted employees. Okay, this is simple concept. Once it is created, it is just like a table. So if you want to see something, you can simply treat it as a table. Okay, so this is all about view, and I will suggest you to create view using this concept. Do some aggregate operations, create a view. Do some distinct operations, create a view. And then you try that whether you can update it or not. Then these concepts will be set in your mind. Okay, bye. Happy learning. Today we are going to learn about window functions in SQL. Let me first read out the definition. A window function is a function that performs calculations across set of rows related to the current row within a specified window. Unlike aggregation functions, window functions do not collapse the result into a single row. The definition may not be clear to you, so let me show you first example, then I will again come back to the definition. I have created a table. In this table we have employee ID, employee name, department ID, salary. Just let me draw the table once. We have employee ID, employee name, department ID and salary. Okay, we have all these details. Now if I ask you that give me the sum of the salaries for each department. See, this you can do, select sum salary from table name. This will give you the total sum, right? Total sum. But you have to calculate sum of salaries for each department. See here, for department ID 10, what is the sum of salary? For department ID 20, what is the total salary? That is your output. So you have to write group by department ID. You know these things. So it will give you, you have to select department ID also. Right. Now let me show you. See, department ID, what is the salary, total salary as per the department ID. But the question is not same here. The question is while still displaying individual salary. So see, so your output will be here. Everyone's name will be there. Alice, Alice's employee ID, Alice's department ID, Alice's salary. Then you have to show the total salary column. So you have to write total salary. So here the total salary column will be there. Next row, employee ID 2 for Bob, department ID maybe 10 or 20, Bob's salary. Then you have to show the total salary. You understand? You have to keep every row, every individual's details with the total salary of their department. This is the question. So see the definition now. Aggregate functions collapse the result into a single row, but unlike aggregate functions, window functions do not collapse the result into a single row. So if you can show that this result, this is not collapsing into a single row, this is called the window function. Okay, so now let's see how to use this window function. Okay, so I am not going to use group by, right? So I will first, let me select what are the columns I want to keep. Let's say I want to show every column. So employee ID, employee name, department ID and we have salary. This is the table, all the columns from the table. Okay. Now I will calculate sum of salary, right? So I will write sum of salary. Now see, this is the clause called over clause. So over partition by department ID. This is how you will write. Now it will do the same thing as group by clause, but it will show the individual salaries also, individuals details also. So you have to use this over keyword, and in the bracket you have to write partition by what. This is actually you are grouping by department ID. So same here, you are partitioning by department ID. Okay. So make a partition for department ID 10 and another partition for department ID 20. That's what you want to say. And from the table name. So now let me just show you the output ones. As we expected, employee ID, employee name, employee's department ID, employee salary. And now sum of salary partitioned by department ID. So for 10, this is the total salary. For department ID 20, this is the total salary. Okay. So you can see that with everybody's individual row, you are just putting their sum of salaries. Okay. Clear. Now let's do the second one. Let's say rank employees in each department by salary. So see the table. You have to rank them as per their salary. So the person who is getting the highest rank will get 1 rank. Second one will get 2. Third one will get 3. Got it? So how can you do this? Tell me. First you have to sort them in descending order, right? So I can write select salary. Let's say I'll select all of them. Let me just copy this. Them from employee order by salary DSC. If I do this one, let me just show you once. You will get the salaries in descending order. Now you have to put here rank 1, rank 2, rank 3 in this way. Okay. So you will write rank. This rank function will give you the rank. Okay. Now you have to group them over partition by department ID. You are doing for different departments. Once you make the partition, now you have to order them by salary DSC. Same. So order by salary DSC. Once it is done, close it. Now write from table. You get it? You are selecting employee ID, you are selecting employee name, department ID, salary, and then you are making a partition and giving a rank. Okay. So you have to use rank clause and the same as usual over clause. Clear? Now see. Employee ID, employee name, department ID, salary, and see the rank. First one 90,000 got 1 ranked. 85,000 2. 85,000 again 2 because they are getting same salary. Now see, for 75,000 it is 4. So 3 is missing because 2 times 2 is used, that's why 3 is missing. So let's say if you want that you don't want to skip anything, okay, this is fine, they are getting rank 2, but this one you want as 3. Maybe this is your need. So in that case, you just have to use the same one, but you can write dense rank. Okay. Okay. Now if you want, you can change the name of this column, right? For that, you have to write as the name you want to give. Let's give some other name. Okay. Okay, this way you can change the name. Now this time you can see 1, 2, 2, 3. Okay. So earlier it was only 4, but now it is 3. Okay. Without leaving any gaps. This we have done. Next one is row number. Let's say I want to assign unique row number to each row within a partition and ordered by salary. Okay. Now you can easily write select. Same thing. Let me just copy. I want to select everything. With that I want to give row number. So you just have to write row number over same partition by department ID, and you can see ordered by salary. So the same thing, just copy, right? And if you want, you can give as row number from employee table. Now let me show you. See, 1, 2, 3, 4 for second department, 1, 2, 3. Clear? Okay, now the next one is get the highest standard in the department. So you have to, what will be the output? You have to write everything, employees ID, employees name, department ID, salary, then there will be who is getting highest salary. Okay, highest salary's name. Maybe let's say Alice. Now again you are writing details above 90,000 and who is getting salary. So let's say 70,000. So you have to write Alice. Okay, so with every employee you have to mention who is getting the highest salary. That is our output. Okay, now let's see how can we do this. So you have to write select, and again I'll select everything. So let me just paste. Now you have to write first underscore value for that employee name, and then you have to write over same concept, partition by department ID and order by salary. Okay, first you are creating a group of department ID, right? You are creating a group of every department ID. You are making the salary sorted. Once it is done, now you are fetching who is getting the maximum, right, from employee table. So you are creating a partition of departments, you are ordering them as per their salary, then you are taking which one is the getting the maximum salary. Now let me show you. Alice. Alice is getting for department ID 10 and Eve is getting for department ID 20. Okay. Now let's do the next one. Let's say I want to know who is the lowest earner. So you can understand this will be the exact opposite. So instead of first, you just have to write last. Okay, so first let me show you the output once. See, Alice is getting 90, Bob is getting 85, Charlie is also getting 85, David is getting 75. So lowest one is 75,000. So it should be David everywhere, but it is not. Why so? Before explaining this, let me tell you how these rows are actually calculated while performing. There are different ways by which it can be calculated. First one is rows between unbounded preceding and unbounded following. If I take any row, let's say Eve. So while calculating anything on Eve, I will consider unbounded preceding on all the rows which are coming before Eve and unbounded following. That means all the rows which are after following. So we can simply manipulate this. Let's see all the cases one by one. I want to calculate total salary of all employees and display it for every row. Total salary of all employees. Let me show you. So I just want to first calculate the total salary. Then that salary will be after every row. So Alice, all the details of Alice and the total salary. Okay. So let me show you how can I do this. So I will write select. I have to select everything. So let me just copy this. All the details. Then I will calculate sum. So sum of salary. Done. Now I will use the over clause. So over, here I am not making any partition because I am not doing as per the department. I am taking all the employees. So I can simply write order by employee ID. Now if I write from employees. Now let's say employee. Now let me just show you what will be the output. You can see that the total salary is different for everyone. So that is not expected. So by default, this is calculated in a different way. If I want it to be applied on everybody's salary, then you have to write rows between rows between unbounded preceding and unbounded following. Okay. Now if I run this, now see, now there is a change in the output. You can see everyone's salary is equal. So the total salary is calculated. Okay. Now you can understand that here, whenever I have taken, let's say I have taken David. So whenever I have taken David, I have calculated all the rows before David, all the rows after David. Unbounded preceding, unbounded following. Clear? Now let's do the next one. Rows between unbounded preceding and current row. This is the default one also. If you don't mention anything, this will be done. Okay. So what we did just before, let me just copy it. And if I write rows between unbounded preceding and it said current row. Let me first show you, then I'll explain. See, unbounded preceding and current row. Let's take if. So, what is the unbounded preceding? That means every row before if 90,000, this one, this one, this one, let's say this one 90,000 plus 85 plus 85 plus 75,000. All these are calculated and current row and 95. So, Frank and Grace are just avoided. You understand? Let's take another example. Bob. Unbounded preceding, that means Alice and current row and Bob itself. And all others, Charlie, David, Eve, Grace, all are ignored. So 90 plus 85, you can say 175. Right? So in this way, you can calculate. So this will give you the cumulative sum because you can take that current row and unbounded preceding. So it's simply a cumulative sum. So whenever you want to calculate cumulative sum of salaries, you can prefer this one. Okay, and by default also this is the output. So if I just don't write anything, then also it will be the output. Okay, now see, in our last question we exactly used this default one. Now let me explain why it was like that. Now you can see that 90,000, 85,000, 85,000, 75,000. Every time it has considered unbounded preceding and the current row. Okay, that is why the result was different. Now, if I want to compute total remaining salary including current employee and all after. Okay, so simply same thing. I'll just let me copy this one. You are doing the same thing, but you are calculating it in different way. Now you are calculating current row and unbounded following. So now just rows between, this will be current row. Just let me show you. Now see, take Frank. As I said, current row, so Frank will be considered, and unbounded following after Frank only Grace. So 85 plus 80. So if you add them, then it will be 165. Right? If I take Charlie, so current row, so Charlie 85 and unbounded following. So plus 75 plus 95 plus 85 plus 80. So all these are added here. Alice and Bob are ignored. So you understand when we are prioritizing which one. Depending on that, you can write these queries. If I want rows between 3 preceding and current row, then you can simply write the same thing, but just write 3 preceding. So just this way you can paste here. Now if I show you, now see, if I take David, then only 3 preceding. So Alice will be considered, Bob will be considered, Charlie will be considered, and current row, and David will be considered. So if Frank, Grace, they are ignored. Let's say for Frank, 3 preceding. So Charlie will be considered, David will be considered, Eve will be considered, and current row, and Frank. Alice, Bob ignored, Grace also ignored, right? Let me show you one more. Rows between current row and 3 following. Just let me copy. Same. You just can between current row and 3 following. Just let me show you. For Charlie, this will be current row. So Charlie will be considered 85 and 3 following. So David will be considered, Eve will be considered, Frank will be considered. Grace will be ignored, Alice, Bob is also ignored. Okay, so you understand in this way, you can write 3 following, 1 following, 2 following, anything. Rows between 1 preceding and 1 following. So what will happen? Only the first one, the previous one and the next one. Rows between n preceding and n following. So simply you understand the concept that depending on your need, you just can simply write in this way and your calculations will be changed. Fine. Now let's say I want to calculate the second highest standard in the department. So we can write select, just let me copy this. Now write nth value and here I want the name who is getting second highest. So I will write 2. Okay. If you want third highest, then you will write 3. Now you will write over. Here I am considering every department, so I can just write partition by department. Okay. Now partition by department ID and I will do order by salary DSC. Okay. Now you can give a name as second highest from table name. Now let me show you. So you can see who is second highest. For first one Alice you cannot find who is the second highest, so that is why in this way. Now you can use this one, whatever you have learned, that whom you want to consider, rows between unbounded preceding and unbounded following. If you just copy this and now let me run this. See. Okay. So depending on which rows you want to consider, you can change. Fine. Now the next one, lag and lead. Lag, just you know what is lag. The previous one, lead, who is leading you. So the previous row salary will give you by lag and the next row salary you can fetch by lead. Okay, let me show you some example. Select. Let me copy this. Salary. Now use lag. Salary, 1, 0 over same. You just want to partition by department, salary DSC and from employee table. Now see lag for Bob, Alice is the last one salary, so Alice's salary is fetched. For Charlie, Bob, so that salary is fetched. For David, the last one is Charlie, so Charlie's salary is fetched. For let's say Frank, the last one is Eve, so Eve's salary is fetched. Okay, you can understand. For the first one, there is no previous salary, so that is 0.00. Same here for group ID 20, no previous salary, so it is 0.00, right? What about lead? Let me just copy this. Now I'll write, instead of lag, you just have to write lead. So lead, salary 1, all other things are same. So now let me show you. The next one. See, for Alice, Bob is fetched. For Bob, Charlie is fetched. For Charlie, David is fetched. But for David, there is no next one after David. That is why 0.00. Same here for Grace, there is no next one. So this is 00. Okay. So you can find the previous row salary or the next salary. Okay, and one more thing I forgot to tell you in case there is a confusion. If you simply just delete this one and if you just execute this, you can see that this also work. Okay, so it's not that always you have to write something inside over, not like that. If you need, then only you can manipulate. Okay, so over simply means that it will go over through every rows. While doing group by, we were doing based on the group and we were just collapsing it. Okay, but in case of over, you are not collapsing it. You are calculating the aggregate functions. You are calculating the salaries, total salaries, average salaries, but you are also keeping their individuals salaries. Okay, so you are going over every row. Okay, so I hope the concept is completely clear to you. If you like, please like and subscribe to my channel. Thank you. Bye. Happy learning. Today we are going to study about common table expression. Common table expression means creating a temporary table while executing any query. How, that we will see while doing any example. See, first I have created an employees table. Let me just show you the table once. Employee ID, name of the employees, department, their salary, their tenure and their hiring date. Okay. Now, my query is find employees who earn more than their department's average salary. First, you have to calculate every department's average salary. What is the average salary for HR, for finance, for IT? You have to first calculate their average salary, and you know how to do this by using group by. Once you have done this, now what is in your original table? The employee table. You have ID, you have name, you have salary, all the details. So now what will you do? You take Alice, you take Bob, you take Charlie and check their salary. If greater than the average salary, then keep it in the result. Okay. So you understand that step. This is the first step where you have to calculate the average salary of departments. Second step, you have to take the original table and you have to check their salary with this one. Right? If it is greater, if the condition satisfies, keep it in the result. Okay? Right? And this table is the temporary table. Okay. So let's do the query, then you will understand. First, we have to calculate department's average salary. So I can write select department comma average salary from employees group by department, because you have to calculate for every department what is the average salary. So you have to use group by department and aggregate column will be average of salary. Let me just show you once. See, the HR 50,000, IT, finance, you have got department and their average salary. Exactly this one we have achieved. Now we have to store this result into this temporary table. Okay, so now let's write this. This is what is common table expression. Because you have to store this result into a table, that you will do using with keyword. So with, let's say department salary, this is the name you are giving to the table, and as keyword, and you have to keep this result inside this bracket. Okay, now it will create that particular table. So you will have this table. This table is now stored as department salary. Clear? So two keywords you have to use, with and as. And inside this you are keeping the result which you want to store as a table. Okay, now this temporary table will be used to compare with the original table. Now let's write this. So you can write select ID, name, department, salary from employees table. Now you have to compare this original table with this temporary table. So first you have to join these two tables and you will join on some common column. Common column is the department column, right? So first do the joining. So we will write from employees E, join, that means inner join with department salary table. This is the temporary table. right? See, the same name you have to give for joining, and give it a name, let's say D. Now you have to do the join on some common column. So D dot department equals to E dot department. This is the common column. Okay, now our joining is done. So once we have joined these two tables, now we can compare. Okay, now let's write the comparing condition. So we will write where this salary, the salary of the employees table is greater than this one, right? So let's write the condition. So we can write E dot salary greater than D dot average salary. So it's better if you give it a name. Let's say average salary. So now we can write average salary. Okay, so you understand. First we have fetched the table, the first table by group by, and kept it in a result. The name of the table is department salary. Now we are taking the original table, we are joining with this department salary table, with the temporary table on some common column that you know, simple joining concept. Once it is done, now you are doing the comparison to check who earn more. Okay, so here I have to write E.id, E.name and E.department and E.salary. Okay, because these are from employee tables. Now let me just execute this. See, for HR salary was 50,000. You remember 50,666. See, Grace has 52,000. Okay, so all of them, David, Frank, Grace, their salary is greater than their department's average salary. Okay, but remember one thing, this temporary table is only for this query only. For next query, you cannot use this temporary table because this is temporary. It is created only for this query. Once the query is executed, the table is gone. So let's do the next one. Identify employees with longest tenure in each department. So simply you have to tell, let's say in HR. In HR, Alice's tenure is 5. Charlie's is 6. Grace 4. So who is the highest? Charlie. So you have to tell that in HR, Charlie has the highest tenure. Right. For IT, Bob is 3, David is 2, Hank is 6. So for IT, Hank is the output. Okay, so you understand there will be Charlie for HR, Hank for IT. Now how can we do this? So first we can take the original employee table. Okay. Now what we will do? We will do the partition, window function. First we have to partition. So I will write HR and all the details, ID, name, and this way I will make a partition of HR. So once the partition is done, now I can write finance. Once it is done, then we can write IT. Okay, so I will do the partition as per the department. First, now once it is done, now I will take tenure and sort them. So first one will be 6, next one will be 5, next one may be 4, maybe 3, 2. In this way, they will be sorted. Okay, maybe for 6, 1 in this way. So now it is sorted. So once it is sorted, so sort in descending manner. Once it is sorted, now you can give them a rank. Rank, you will just put 1, 2, 3 for finance, again 1, 2, 3 for IT, again 1. So this way it will be ranked. Now as you have this one, now you can simply fetch which is the first rank holder for HR and its details, which is the first rank holder for finance and his details, which is the first rank holder for IT and his details. Okay, so you understand what are the steps. First, you have to partition by department. Second, you have to sort in descending order. Third, you have to give them a rank. Fourth, you have to fetch who are in the first rank position. Let's do the query. Okay. So, first, I'll write select ID, name, department and tenure, then give rank. Rank function will rank over, this is the window function, and we have to do the partition by department, right? Partition by department and order by tenure in descending order. Okay, so once the partition is done, ordering is done, now you have given the rank. So our job is almost done. Now from table name, give it a name, otherwise, so we can give tenure rank. Okay, now let me just show you what is the output. See, finance, this is the 1, 2, 3. For HR, 1, 2, 3. For IT, see, for IT 1, 2, 3, 4. Exactly as we expected here. Right? This way it has been sorted. Okay. Now we are going to fetch who is holding the first rank. So I have to keep this result in a table. So now I will write with give a name longest tenure as, and keep this in this result. Okay, so now this is saved in as longest tenure. So now this is saved as longest tenure. This is our common table, or we can say our temporary table. Okay, now I'll fetch select star from longest tenure where, what is the condition? Can tenure rank is 1, so I can write tenure rank equals to 1. Okay, because your name was, let me just show it to you once again. This is the tenure rank, so you have to fetch where the tenure rank is 1. Okay, right? Now let me run this. See, first tenure rank all are fetched for finance department, for HR department, for IT department. Okay, so you get the longest tenure in each department. Clear? Okay, now let's do the next one. Identify employees who have the same salary as someone else. You have to find who is getting same salary. Let's see, Alice. Alice is getting 50,000, Charlie is getting 50,000. So see, both of them are getting same salary in HR department. Okay, so you have to find who are getting same salary. That means more than one people are getting the exact salary. So let's first see what are the steps we have to follow. First, we have to take all types of salary. Maybe 50,000 is a type of salary people are getting, 60,000, 75,000. So once you get that, now you have to calculate the count. 2 people are getting 50,000 salary, 3 people are getting 60,000, 1 people is getting 75,000. Now our question is that same salary as someone else. That means more than one people is getting. So I can simply remove this. So you have to show this too. Okay. And you have to also give their details like ID, name and all these things. Okay. So our first step will be to calculate this table. Then you store this temporary table into something. Okay. So let's do it step by step. So I can write select. So I can write select salary comma count star as salary occurrences from table name, and we will group by salary. See, if you see the table, we are grouping on the based of salary column, right? So group by salary. Now let me just show it to you once. What is the output? See, 50,000 is a type of salary, 2 people are getting. 70,000, 1 people. 75,000, 1 people. So you can understand that our output will be these two. Okay, so we have to find which are the 2 people getting the same salary, right? So this is the salary. Now for 1 we have to discard that one. So we can write having count of star greater than 1. So that will be discarded. Now We have only left this one. Okay, now from this we have to find who are the employees. Okay, so what do we have to do? We have to now store this in some table. So we can simply write with salary same, or just give a meaningful name, same salary as, sorry, with same salary as this one. Okay, now it is stored in this temporary table called same salary. Okay, so we have 50,000 and 2. Now we are going to fetch the details. So select ID, name, whatever columns you wish to see, department, salary from employee table, right? And you have to join with same salary table. See, here we had this first step that is done. Now we will take the employee table and we will join on the basis of common column. Common column is the salary column. So we have to join the original table with this table based on this common column. Second step. So I am joining with same salary. Let's give it a name S on S dot salary equals to E dot salary. Salary is the common column, right? So now I have to write E dot ID, E dot name, E dot department. Okay. So if you get that same salary, like 50,000 is the salary, and here you get 50,002, so then you can fetch their details from this original table. Let me just show you the output once. What happened? I said employees. I'm sorry. Okay. Sorry. Salary. E dot salary. Now see, Alice and Charlie, they are both getting 50,000. This is what all about common table expression. If you want me to give some more examples, then please write in the comment section. And if you like, please like the video, please subscribe. Thank you. Bye. Happy learning. Hello everyone, welcome back to this channel. Today we are going to learn about functions in SQL. Functions is used to perform any operations. Okay, it is simple, just like Python. You take some input, you do some job, some operations you perform on that, then it will give you the output. Okay, now functions is of mainly two types. One is inbuilt function. Inbuilt function we have already used. You can see string functions, upper, lower, numeric functions, round, floor, date functions, aggregate functions, conversion function. These are inbuilt function. These are already created in SQL. All you have to do is to call the function, right? But there are one more types of function, that is user defined function. That means you can create the function by yourself. Okay, so you have a choice to create your own function and then you can call the function to perform any work. Clear? So today our topic is user defined function. Let's do some example, then things will be more clear. I have created an employees table. Let me just show you the table once. We have ID, name of the employees, monthly salary, marks, date of birth. Okay, now we are going to write some functions. Our first question is annual salary calculator. How can you calculate annual salary? See, in the table we have monthly salary. So if we just multiply it by 12, then we can get the annual salary. Okay, so now let's write the function. So first you have to write delimiter. Why it is used, I will tell you. Delimiter space double dollar. Then you have to write create function and you have to give a function name. Annual salary calculator. Okay, now I will give which one will be the input. So here our input is monthly salary. And what is the input data type? That is decimal. 10, 2. That you can see from here. See here, monthly salary, decimal 10, 2. Okay, this is the input. Once you have told about the input, you have to say which one will be the output. So you write returns and output is also, let's say, decimal types. Okay. I can write begin. So inside the function, I will write return monthly salary into 12. That will give you the annual salary, right? Now once you have written, now you can write end. Okay, so the operation is done. First we have given the input, then we have stated which one will be the output, then we have written which is the operation. That will be written within begin and end. Once you have end, now you have to close the delimiter. Okay, now one thing keep in mind, while writing delimiter, you have to write it in capital. Okay, SQL is usually case insensitive, but in case of delimiter, you have to keep it in mind. And there will be a space, then you can write $, then you write create keyword, function keyword, give a function name as per your wish, and input, what is the data type of the input. Then you say what is the output, what is the data type of the output. Okay, now you have to write deterministic. Deterministic means for one single query you have to give one output query. Begin return monthly salary into 12. Here you have to provide semicolon, then you write end. After end you write the dollar symbol which you have started here, then you write the delimiter keyword again to complete the delimiter. Okay, now let me tell you one more thing, why delimiter is used. See here, in the end I have given a semicolon. Every time you write a query, you have to put a semicolon at the end. That means the statement is ended. But while writing a function, we may need to put the semicolon multiple times. So it may get confused when to end the statement, because this is not a single statement, it is a big thing. So that is why you start it with delimiter, you end it with delimiter. That means please ignore this semicolon. Don't think that the statement is completed. When you get delimiter, then you think that the statement is completed. So delimiter means you are saying that it is a complete single thing. Okay. Now let me just run it. So see, the function is created. So if I refresh it here, here you can see functions. Inside this you can get annual salary function. Okay, now if you want you can simply check. So I can write select and you have to call the annual salary function, annual salary calculator, and there you have to pass monthly salary from employees table. Now if I just run this, see, you can see monthly salary 5,000, 7500, 6400. So it is multiplied by 12. Okay, clear. Or if you want you can pass something by yourself. So again I can write select annual salary calculator, and here if I write 100. Okay, so it will be 12,000. Just see the output. Okay, so you understand, you can pass the input by yourself or you can take it from any table also. Clear? So this will give you annual salary calculation. Now let's do the next one. It's simple interest calculate. You know how to calculate simple interest. P into R into T by 100. P is the principal, R is the rate of interest, and T is the time of investment. Okay, now let's write the function. So first I have told you, you have to write delimiter in capital. Start it with $. Now I will mention the function. This you can write in caps or small, whatever you wish. Give it a name. So interest. You have to give the input. So I will write P, let's say integer. R, rate of interest can be decimal value. So it is better if I give decimal. T, integer, let's say. Okay, you can give any data type. Now I will write return. So it will return, let's say decimal 10, 2. Okay. Now I will write the function. So I will start by begin, and inside this I will write return. Sorry, here it will be returns. So return P into R into T divided by 100. So this one. Okay. Put a semicolon. Once you have done this, you have to finish it by end. And after end, you have to give $sign. Now it is done. So again, you have to write delimiter in capital. Put a semicolon. And before you start begin, you have to give deterministic. Okay, now let me just show you the output. Function is created. See, this is the interest function. Okay, now if you want, you can just pass select. You have to give the function name, and here let's say I want to calculate P as 1000, rate of interest 10% for 2 years. So now you can see the output. Okay, this is the interest you will get, simple interest. If you have invested 1000 rupees at 10% rate of interest for 2 years, that will be your output. Okay, so you understand, in this way you can write a function. Now let's do another one, grade assignment function. See, you have to give some grade. Maybe if the student has got greater than 90, you can give A, greater than 80, you can give B. In this way you can write the function. So first I will write delimiter space $. Now you can write create function, give a function name, let's say grade, and you have to give input as marks. Marks is a, let's say, integer. Okay. Now what will be the returns? Return will be A or B, so it will be a varchar, let's say up 2. Okay. Now you can write deterministic. We will start inside this. We will write if else statement. Okay. So if marks greater than equals to 90, then return A. Let's write it in capital. Okay. A. Else if marks greater than equal to 80, then return B. B. Okay, in this way I can give 2 more. See, now else if marks greater than 90, A, greater than 80, B, if marks greater than 70, then return C, and the last one I will write only else, not else if. Okay, so any number you can give else if, but at the end you have to give else. All the 3 conditions are not satisfied, so I'll write D. Okay, now once you have completed this if statement, now you can write end if. Okay, so you start by if, the condition satisfied, else if, condition satisfied, else if, not satisfied, else. Once it is completed, now you write end if. Okay, so now here you can write end $. Okay, now write select first let me create the function, then I will show you. So there is an error. No, sorry, there must be a space. Okay, so now let me run this. Now I think our function is created. Interest function is created. Now you can write select grade, and inside this I will pass, let's say, 90. Now see what will be the output. This will be A, return A. Okay. Now if I want to apply it on the table, in employee table we have once marks, so we can just write select grade from marks table, from employee table. Okay. So that means from employees table on the marks column, please apply this function and give me the grade. So VAD, you can check it from here, 82, 92, 58. Okay. The next one is Fahrenheit to Celsius converter. This is simple. I'll give you this as a homework, so you can do it. I can tell you just have to write delimiter, you have to create function, you have to take some input, you have to same way, you just have to write and all the functions. Okay, then you write select and give any number and check whether it is converted to Celsius or not. Okay, if you can't, then let me know in the comment section. If you have done, then also let me know that you have done. Okay, so this is all about function. Bye, happy learning. Today we are going to learn about stored procedure in SQL. It looks like a function, but there are some differences with function that we will learn. But the definition is the procedure is a set of steps that you write once and you can reuse it later multiple times. Okay, so you don't have to write the same query again and again, but you just write it in a procedure format and you can simply call the procedure. Let's see how. So before that, let me just show you the table. This is the employee table. I have created ID, name, salary. Okay, simple small table. And using this, we will learn how to create a procedure. Okay, so first one is in procedure. Get employees earning more than a certain salary. See, if I tell you to write this query, can you write this? Yes, you can simply write select name from table name where the condition. Now this SQL statement I will write in form of procedure so that I can simply call it later and I don't need to write the same query again. So first let me write the query. Select employee name, salary, just a minute. Let me see the name, only name, sorry. So select name, comma, salary from table name where salary greater than minimum salary, right? So whatever the minimum salary is. So whenever you want to see, you just have to write the same query, but I just don't want to do that. I will write it in a procedure. So I can write this by using create procedure, a name, let's say high paid employee. Here I have to pass the minimum salary. What is the minimum salary? That is whatever you want to provide, that will be passed as an argument, and it is a decimal data type. Okay, so once you write this, now you have to write begin. Inside begin you will write this query, whatever you have written here. Okay, now you have to give end, but this will not run, so I have to write delimiter. You may not need if you are using something other than MySQL Workbench, but if you are using this one, then you have to give the delimiter. Okay, and you have to write this. So now if I simply run this, the procedure will be created. Sorry, here I forgot to give one bracket. So now let me run this again. See, the procedure is created. If you refresh it here, table view stored procedure. So just click here. See, high paid employee. Okay, now how can you call the procedure? So the way to call the procedure is by writing call the procedure name, and here you have to pass the minimum salary. So let's say 50,000. So I want to see all those employees who are getting more than 50,000. So Bob and Charlie will be our output. See, Bob and Charlie. Okay. For function you have used select, but for procedure you have used call. And there are some other differences I will tell. Wait. Now let's do the next one. Out procedure. This one you can see this is in procedure. I have taken an input. Okay. But let's say I want to see the total number of employees. What is the SQL code? Select count star from table name, right? This is the SQL query, but I want to create this as a procedure. So create procedure total employee and out total integer. Okay, you start it with begin just like you did in function. Once you have written, put a semicolon, give end. Now you give the delimiter. Okay, here also you have to start with delimiter. Now let me execute this. See, it is created total employee. Okay, now if I want to see call @total, I have to give the name. Sorry, call total employee @total. Now let me show you 3. Okay, you can see 3 people. Now let's do the next one, in out procedure, that I will tell you later. Before that, let me tell you how to add a new employee. I will write insert. delimiter, create procedure, procedure name, add employee. Data type, you have to give new employees details, so you have to pass in employee name and employee salary, right? So employee name is a varchar and employee salary is decimal data type. Okay, so you understand, you have to give the employee name, employee salary, you have to mention their data type. Now I will begin, and here I will write the code for insertion. So I can write insert into table name, salary column, and what will be the values? What we will pass here? That is employee name and employee salary. So I have to write values employee name, comma employee salary. Okay, put a semicolon and delimiter. See, now if I run this, see, insertion is done. Sorry, the procedure is created. So add employee is the procedure. Now I want to insert something. So you have to write call. You have to pass employee name, Mike, and salary, let's say 55,000. Okay, and procedure name, add employee. Now see, if I refresh this, let me show you the employee table. See, this is inserted. Now update. How can I update? By employee ID. Okay, I have to give delimiter, create procedure, update salary. You have to take the salary. So employee ID, that will be integer data type, and one more you input, that is new salary, by which you are going to update. So new salary, that is a decimal data type. So 10 comma 2. Okay, now start begin, and inside this you have to write the update. So update employees set monthly salary equals to new salary. Sorry, it's not monthly salary, our column is salary, so salary equals to new salary, and where condition is id equals to employee id. Not for everyone, for whom I will give you the id. Okay, once it is created you write end. Oh sorry, end, and here you have to give delimiter. Okay, now let me show you. Refresh here, see, update salary is created. Okay, now I'll update someone's salary, so I will call procedure name, and here I'll, let's say, employee ID is 2. For 2, what is the salary? 60,000. I'll make it 80,000. So I will pass 80,000. Okay, employee ID you have to pass, new salary you have to pass. Now, so it is done. So if I click employees, see 80,000. Now delete. How can I delete? First let me create delimiter. Now I will write create procedure delete employee, and here I will pass only employee ID, right? Integer, because I will delete by employee ID. Begin and delete from table name where ID equals to employee ID. Okay, semicolon, and dollar symbol, I'm so sorry, delimiter, and semicolon. Okay, so take the employee ID, that is integer data type, and delete where the condition is matched. Now let me create the procedure. Procedure is created. Yes, delete employee. Okay, now let's say I want to delete Bob 2. I want to delete 2. So I can write call delete employee. Employee ID is 2. You have to pass only one argument. So now let me show you. See, I think it is created. If I refresh, see. Okay, clear. Now conditional out. Before that, let me tell you this one. the in out procedure. Add bonus to given salary. Okay, so let me show you how you can use in and out both together. Okay, so we can write create procedure update employee salary. Okay, now I will pass in. First you have to give employee ID, which is integer data type, and output will be updated salary, that is a decimal data type. Okay, now begin, and inside this, see, I'll write first I have to update the salary, so update table name set salary equals to salary plus 5,000. Let's say I will update their salary by 5,000, where ID equals to employee ID. Okay. Let's say if I send 2, and then for employee ID 2, the salary will be updated by 5,000. Okay, so updation is done. Now I want to see the updated salary. So for that I have to write one more query. So I can write select salary into updated salary. So this salary will be into updated salary from employee table, where ID equals to employee ID. So in both scenario you have to give semicolon. Now you can write end. Now delimiter. Okay, here also you have to give delimiter. Now first let me run this. Procedure is created. So we have update employee salary. Okay, now let's say for 4, for Mike I want to delete. Sorry, I want to update. So I'll write call procedure name. For 4 I want to increase their salary by 5,000. So I have to give 4. This is for employee ID, and for updated salary you just have to write this updated salary. Now let me show you. See, updated salary is 60,000. Earlier it was 55,000. So 5,000 has been added. Okay, clear? So this way you can update. You can use in and out both together. Fine. Now the last one, conditional check if the employee exists or not. Okay, so I can write create procedure check procedure name, let's say check employee, and you have to pass employee ID as integer data type. Okay, so begin. Now here you can write select count star from employee table, where ID equals to employee ID. Fine. And $sign delimiter, and you have to start by delimiter. Okay, so employee ID will be taken as input. It will check if what is the count, and then you have to keep it in, let's say, exist flag. Okay, so here also I have to give output out exist flag. Okay, conditional out. If it is there, then the output will be given to you. Okay, that is why the name is conditional out. Let me run count star into exist flag from employees. Why error? Okay, sorry. Out exist flag, I forgot to mention integer data type. Now see, now it is created, so you can see check employee. Okay, so now let me call check employee, and let's say I want to check for Bob. For output also you have to mention @ say exist flag. So okay, so you understand, this is how you can create different kinds of procedure. Now what is the difference between function and procedure? While using function, we used to return some value. We always wrote something returns. After this statement we mentioned return, and you have always seen that function returns something, but in case of procedure it doesn't return anything. Okay, that is the main difference between function and procedure. And function is mainly used for computing and returning a result, and procedure is mainly used for performing any sequence of action. You can see that some actions are performed. Okay, so you understand the difference between function and stored procedure. Okay, bye, happy learning. Today we are going to understand about set operations in SQL. Union, union all, intersect and except. Okay, I have created two tables. One is customer table. Let me show you just once. We have ID of the customer, name of the customer, city of the customer. Same columns for employee table. ID of the employee, name of the employee, city of the employee. Okay, now we will execute some queries using these operations, these particular keywords. Okay, but before that, let me tell you about these keywords. Let's say you have customer table, employee table. You can consider that this is city of customer table, city of employee table. Now for union, if you use union, then you will get all the cities from customer table and all the cities from employee table. Okay, it denoted as A union B. So when you write A union B, that means you are taking all the values from A table and all the values from B table. A is the customer here and B is the employee here. Okay. Union all means that you take the duplicates also. Okay. That means don't leave the duplicates. For only union, no duplicates. We will see while executing queries. Okay. Another one is intersect. Intersect means only those portions which is common. This one. This is denoted as this way. A intersection B. That means only those cities where there is a customer and there is an employee. Customer is also existing here and employee is also existing here. That portion is called as intersect. So you understand, union means all of them complete. Intersect means only the common person. Okay. Now except, that means let's say I write A except B, or in some cases you can see A minus B. That means take all the values from A but minus B. Leave the values of the B. Okay, so only this portion, only this particular portion, not this one. Same way, if I write B except A, then you have to take all the values from B but not that portion which is included in A. Okay, you get my point? So these are the main terms. Now let's understand this while doing queries. See, our table is ready. So now my query is all the cities from both tables. I have told you all the cities from both tables means you want this, exactly this one. And without duplicates, that means you have to use only union. So how to write this query? Select, simple, city from customer. This will give you the city from the, customers. So this will give you city from the customers table. Right? Now if I write select city from employees. Now let me show you. If I run this, it will show all the cities from employee table. Now what you have to do? You have to write union. That means give me all the cities where there is a customer and an employee. See, there is no duplicates. All the cities are only ones, but there are duplicates you have seen in the table. So same query when I want with duplicates, let me just copy this and write union all. Then see what happens. See, Chicago, Seattle, Houston, Miami, New York, Chicago, Houston. Okay, so you can understand there are duplicates. So if you want all the cities with duplicates, you have to use union all. If you don't want the duplicates, then you will not write all. You will just write union. Okay, you understand the difference. Okay, now let's do this one. City is common to both employees and customers. Common portion means you have to find this portion, the intersect portion. Okay, this is the customer table, this is the employee table. You have to find where a customer also lives and employee also lives. That is the common one, that is intersect. Okay, so just simply you have to use the intersect keyword. The same thing, let me just copy. You have to fetch the city from both the table and there you have to write data set. Okay, now if I run this, you can see Chicago, Houston, New York. You can see these things are common in both the tables. Let me show you. See, Chicago is common in both the table and the common tables will be fetched using intersect. Now, cities where employees are living but not customers. See, this one where you have employees but not customer. See, this one employee, this one is customer. So, these cities will be considered, but here customer is residing, so this person you have to ignore. So, this is only possible by using except keyword or by using minus keyword. Okay, so just you have to first fetch the city from employees except the city from customer. Right, now let me show you. See, Los Angeles. You can see Los Angeles. You have one employee from Los Angeles, but not from customers. Fine. Now name all the individuals in Chicago. See, in Chicago, Bob is living. In Chicago, Frank is living. So I want Frank and Bob. Okay. So that I can write using select. You have to fetch the name. I will type it as employee. So as type from employees table where city equal to Chicago. Let me first show you this one. What happened? Select name, sorry, comma. See, Bob is an employee. Bob is living in Chicago. So I have just written the type as employee. So Bob, the type is employee from employees table and here city is Chicago. Bob is living in Chicago. But I want from employee table and from customer tables also. So I have to write union. Let's do union all because I want from both the table. So same thing you just have to do from the customer table also. Right? Here this will not be employee, this will be customer. Fine. Now let me show you. See, Bob from employee table, Frank from customer table. Employee table is typed as employee, customer table is typed as customer. Both of them are living in Chicago. So you understand how to use these particular keywords. Now let's do the next one. Total count of unique cities served by employees or customers. So you have to count all the unique cities. Distinct keyword you have to use, you have understood. Now see how to write this one. Select, let's say I'll do count on distinct city. Unique cities. So that's why I'm using the distinct keyword. Let's give it a name. Total cities. Now from where? You have to connect both the tables. So see, select city from employee union, select city from customers. Because you know, if I do this one, select city from employees and select city union all, select city from customers, this will give you all the cities. Now from here, from this particular table, you are counting all the distinct cities. Okay. Give it a name as all cities. Now see the query. Sorry, I forgot to give the underscore and it was a space in between. So that is why it was showing as error. Okay, now see. Select city from employees and select city from customers. Union. This one will give you a big table of all the cities. What happened? See. This is the big table containing all the cities. Now from here you are counting all the distinct cities. Okay, this is simple thing. In the t-type table you have to give it a name, all the cities. Okay. Okay, so total 6 cities. Fine. Now people with the same name in both employees and customers. Is there anyone in the same name? Alice, Bob, Charlie, David, Eve? Not really. But let's run the query. Okay, how to find? Same name in both employees and customers. Same. So you have to select name from employees table. This will give you all the name from employees table. Union select name from customers table. Okay, so this one will show us the total all the name from the both the tables. But in case you want to see only the common one, so you have to write intersect. So as there is no, so it will show as blank. Okay. Now people who are employees but not customer. Same employee but not customer. So employee but not customer. So this portion you have to ignore. Only this one. So you can say this one is except. So you have to write select name from employee, all of them, but so except select name from customers. Same thing. Nothing new. Okay. See, all of them because they are not in customer table. Fine. So we have understood how to use union, union all, intersect and except. Okay. So bye. Happy learning. Today we are going to learn data administration commands, which comes under data control language. That means that in your database you protect your data. You have many users, multiple users, user A, user B, user C, all of them can access your data, right? Let's say you want to give permission for modification of any data to user B. Then what you have to do? You have to set that user A can only access the data. User C can only do particular part of the data, but user B can do the modification of the data. So as an administration, you have to create different users, you have to give different permission to different users, and in case you may need to revoke the permission or you may completely delete the user. So you understand these types of tasks you may have to do to protect your database so that nobody can misuse your database. Okay, different user will get different roles, and who will set those roles? You as a data administrator. And how to do that we are going to learn. That how we can create user, how we can give different kind of grant permission, how we can delete particular user, or how we can revoke that particular grant. Clear? So now let's start and we will understand in details. So this data science sphere, the database I have already created. Let me just refresh this one. Okay, now use this particular database. So in this database we will create the user. Okay, so for the first question is creates a new user named data admin. Okay, so I will create user and here you have to give the name. Let's say I provide data science administration or data science, let's say @ localhost. Okay, so sorry, this is the name. You can provide any name. Okay, so now if I just execute this, an user will be created. Fine, who can log in this localhost. Okay, now sets password to admin @ 1234. Sorry, 123. Here I have not given any password, so the user can simply log in. But you have to provide the password also, just like you give email ID and password. So if you want to set a password for them also, you just have to write identified by and whatever password you provide, admin @ 123. Now if I run this, that means this particular user can use this as their username and identified with this password. As this is once created, that's why it is showing as an error. You just can just give a different name. Okay, so this is the user ID, this is the password. This is how you create a particular user. Okay, now let's say you want to give him some permission. Now this gives the user select and insert privileges on all tables. Okay, in your database you have multiple tables and you want to give permission for selection and for insertion of all the tables. Okay, here our database name is different, so I will use a different name. These privileges allows the user to read, to add, but not update or delete. So you can see select and insert. Fine. So you have to write grant select insert on our database is different here, data science sphere. So I will write data science sphere and you have to give to the all the tables, so dot star. Okay, so as we don't have any tables yet, but if you have, you can. But if you have a particular table, let's say you have employees and you have customers and you want to give them only access to employees table, then you have to write employee table. But here I'll write star. Star means all the tables. Okay. Now to let's say this user ID. Okay. Now you just have to now you just have to execute this. See, so what you have done, you have given this particular user datascience@localhost to access all the tables, to do the selection, to do the insertion. Clear? Let's see show grants. Show grants means see all the privileges currently assigned to the user. Okay, so I just want to see what are the privileges they have so that I can do any kind of modification if I want. Okay, so you just have to write show grants, that means show all the privileges for whom? For this particular user. So you have to write this, right? Just see we have given to do selection and insertion. Clear? If I tell you give them update and delete, then you just have to write grant update, grant delete, then this particular user will be do update and will be able to do deletion also. Clear? So this way you give grant and this way you can see what are the grants provided to any particular user. Now let's say this you want to remove some privileges. You just want him to select but not do any kind of insertion. So you have to revoke. Okay. So let's see how can I revoke. Revoke. Which one you want to revoke? I don't want to give him insert permission. So revoke insert on, you have to give the database name. Here also if you want to revoke permission from all the tables, you can write star. If you want to remove any particular table, then you have to write data science sphere dot that particular table name. Clear? From you have to name the which one is the user. So from this particular user. Clear? Now let me show you. See, done. Now how can you check? If I copy this, paste, so you can see that revoke is done. See, earlier it was select and insert, now it is only select. Now your job is to give them grant an update operation and do the revoke operation for a new user. Okay, so that is your home task. Next one, let's say you want to set a new password. Okay, so how can I set password? So I just write set password for, before that let me create one user. So create user data. Okay, now just show me. Here I have created the user but I have not set the password. Okay, there I set the password as identified by, but here I am setting the password for the user which doesn't have any password yet. Okay, see how it works. For data equal to, what is the password you want to give? 1234. Okay, so in this way you can set password also. Fine. Now if you want, you can drop the user. Let's say that person has left the company, so you just want to delete that particular user account. Okay, so that is, drop user username. Let's say we will drop data. So data, that user we have created also, so you just delete. So that is deleted. Okay, clear. Okay, now let's say if I want to see whether this is deleted or not, so I want to check which are the users in my database. So let's select user host from mysql dot user. Let me run this. Okay, so there are so many user ID. If I want to see just for data science sphere, then we can write select user host from mysql dot db where database equals to data science sphere. Okay, now let me run this. See, we have created this one and this one we deleted the data one, so it is deleted, but this one is still existing. Now let me show you once again. If you just drop user and this one, right? So copy, right, this one, and let me drop this. Now if I run this, see, no user. Okay, so I hope completely clear to you how data control language, how data administration commands works. Okay, so bye, happy learning. Well, today we are going to learn about transaction control commands. That means controlling your transactions. Transaction simply means your insertion, deletion, updation, whatever operations you perform, you can control them. Okay, so we are going to learn about commit, rollback and save point. Okay, let's do examples, then things will be clear. So first let me create this table, the student table. Okay, I have to select a database. So in the company database, I'll create this student table. Okay, now let's see. I want to do some insertion operation into the student table. I can write insert into students values 1, comma, you have to give some name. Let's say Anita and marks 85. Okay, now I want to insert these values. After insertion, I think that this is fine. I want to commit up to this. That means permanently save this one. Commit means you are saving. You are confirmed that this is fine and you want to save this up to this portion. So you have to write begin and commit. Okay, so okay, so you understand, you have committed up to this. Let's see the table once. Select star from students. See, there will be one value and this one you have committed. That means you have saved permanently. Okay. Now if I tell you to do some updation and do the commit, same things, just I want to show you second time. Let me copy. This one you have to change. So I'll write update. Make any kind of updation, like update students set marks equal to increase mark. Okay, so where id equals to 1 for Anita, update her marks. Okay, so okay, now if I write commit, this is committed. Okay, So in this way you can make any transactions and you can do a commit. Commit means you are saving it permanently. Okay. Now in every database you don't need to do the commit, but in some databases after every transactions you have to ensure that you do the commitment. Okay. Now second one, delete and commit. That is your homework. You delete this table, delete this data from this table and do the commit. Okay. Okay. Now let's understand insert and rollback. See here, I have inserted two more values. One is Sneha, number 3, 4 is Amit. Okay. Now if I run this, insertion is done. Let me show you the table once. Select star from students. See, you have Anita, Sneha and Amit. Okay, these are fine. Now if I write rollback keyword will take you to the previous commit. Now see, after doing the rollback, let me show you the same thing again. See, these two are gone. Sneha and Amit are gone. That means roll back to the last commit. Okay, clear? Now, if I tell you to do any update and rollback, that is your job. Just make any updation and again try that to roll back. Let me show you. Let's say for we have only Anita right now. So I will do some updation on Anita. I'll make it 89. Okay, earlier it was 88. Now it is 89. So now let me show you. This is done. So if I do this, see, Anita 89, it is done. But what I will do, I think that no, that is a mistake. It's not 89. It was earlier, it was right. So it is 88. So what I do, I write rollback. Now let me show you. The rollback is done. So just let me show you. See, now 88. Okay, so rollback means you are going back to the previous point. Fine. Now the problem is that, let's see, you have done 5 transactions and first 3 transactions are perfectly fine, but last 2 transactions you think that those are not correct, so you want to go back. Okay, so you have 5 transactions, first 3 transactions you want to keep, last 2 transactions you want to roll back. So here what you do, after certain point you do some save point. Just show you first. Let's say in your table, student table, you have ID, name, marks, right? Now what you do, first one you have done entry, second one you have done, third you have done, fourth you have done some operations, that may be anything, insertion, updation, deletion, anything, and after fifth you have done some operation. Now suddenly you think that up to this it was okay, but last 3 transactions are not fine, so you just simply undo them, you just simply remove them and you want to go back that particular point. So what you can do, you can simply create some save points. Save points means, let's say after this first transaction you have saved it as sp1, after second you have saved it as sp2. So after every transaction or after every 2 transactions, whatever you feel that it is necessary, you are creating a save point. So whenever you want to go back to that particular save point, you can simply write roll back to that particular save point. If I write roll back to sp3, that means you want to roll back to this position. So this portion will be remained and this one will be undone. This one will be simply removed. You get my point? Okay. Now if I say that the first transaction is okay, please undo all other transactions. So what you have to do? You have to go back to this particular checkpoint. So you have to write roll back to sp1. You understand? Now let's do this here. How to do that? So I will write begin, insert into students values 6, Priya 90. Okay. Now what I give? Save point sp1. Okay, now what I do after this, I am giving a save point sp1. Okay, next I insert something else. Let me copy. I want to add 7 and here let's give mic 92. Now I insert the value and I want to create one more save point, that is sp2. Now let me run this. See, sp2 is saved. Now let me add one more. So I will add this. Here I will give 8 John and let it stay same. Okay, now after this transaction I'll write save point sp3. sp3. Okay, sorry. See, 3 transactions we have done. First one sp1, second one sp2, second one sp3. Now at this moment I think that I will keep Priya and Mike but not John. So I want to go back here to sp2 because I want, let me just show you the table once. Select star from students. So if I run this, see, we have Anita, Priya, Mike, John. Now what I want to keep Mike also but not John. So I want to go back to this particular point. So this particular point is saved as sp2. Up to here we have taken a screenshot which is saved as sp2. So here you have to write roll back to sp2. Then see what happens. Now if I write select star from students, see the output. See, John is gone. Okay. Now if you want you can do up to sp1. So in this way after certain transactions you keep a save point, and whenever you think that you have done any mistake or you want to go back to the previous one, you can simply write roll back to that particular point. Clear? So I hope you have understood what is commit when you want to permanently save, what is rollback when you want to go back to the previous position, and what is save point, that is like taking a screenshot up to a certain point so that you can go back to that particular point whenever you wish. Okay, these are known as transaction control commands. Okay, bye, happy learning.